All right, let's go ahead and get started, making sure you guys are in the right spot because we got two review sessions going on right now. In here, this is Fretwell 121. This is the Calculus 2 review session. So if you're in Calculus 2, this is the place to be. If you are in Calculus 1, the review session is in Fretwell 100. Okay. A couple of things here as I'm getting started. I have got part of your test. I'm afraid our grader could not get everything done in complete time. I should have them by this afternoon, he says, as I ordered him to be here this morning. But nevertheless, I will deal with him and have him executed later. But nevertheless, I have the multiple choice parts of your test back. So I at least can get you that part of the thing back to you guys. And so here's the game plan here. Let me put these. Since my section 90 is so small, I just put it in one big folder here. So this is section 90. It'll be labeled section 90. That is the evening section on Tuesday, Thursday. It'll be in here. And because I'm so good with this stuff, this is section 007. This is the old Tuesday, Thursday at 9 o'clock in the morning papers. I have those alphabetized based upon last name of your alphabet and stuff. So I'm going to pass these things out, as well as I have the multiple choice parts of your test going to come back. So put it here and pick out the folder that you need and try to keep them in somewhat order for the next guy. And these are the multiple choice parts of the test. This is the green one, or is actually labeled 007. Make sure you know which section you live in. And this one, it's actually not labeled, is 00090. So there we go. All right, because things are going to go so late in terms of the way we did the semester, I've got another gift for you guys. I thought about this after several people have come by and begged me. Was this. Because we're really working hard on trying to get these papers back to you, because you took the test Tuesday and here it is on Thursday, and we're trying to get them back to you. And with this volume of students, you see what the real issue is. So what I decided to do was, okay, I know I've got this policy that if you do better on the final exam, I'll replace your lowest test grade on test 1, 2, or 3. Well, what the hey? We'll include test 4 because I've seen those grades too. It's just bad. All right. So that being said, I want to remind you there's these evaluations that you guys have to do online. All right. But it'll be easier for me to do it that way anyway. All right. So, however, this is my plan. I'm going to go over the spring 2013 exam, and I just happened to bring a copy of the free response part, and I thought we would just go over this thing as well just to help you guys prepare for what you guys are going to endure tomorrow. By the way, just a thought. And again, I know I got bunches of different kinds of students in here from all over the place, but I'm talking to my students. My students, for you guys, where is your exam going to be at tomorrow? Denny 200. Denny 200, right. What time does the exam start? Well, officially 8 o'clock, but you have to be there at what time? 7:30 in the morning. So get a good breakfast and good night's sleep, and make sure you study hard all day today. All right, so let's go ahead and get started on the spring 2012 common exam here. All right, just like before, my goal here is not just to go over these problems, which is most important. I'm also trying to give you guys strategies. Remember, this exam is going to be in 3 parts. Part number 1 is no calculator. You will be putting your calculators underneath your desk. You will not be allowed to have any electronic devices at all during the exam except for calculators, and that will come in the second and third part. So this first part is going to be no calculator. So if they're going to give me a section of no calculator stuff, what are they going to emphasize? Integration. So be prepared for that. Maybe some sequences and series, because we didn't do that much calculator with that, but you know, a lot of those work problems and stuff that you had to set up those integrals, unless it was real simple, man, you really needed a calculator for that. So let's take a look at this thing. So part 1, no calculator. It's 8 o'clock in the morning. We open our test booklet and we go to problem number 1. And remember, they are trying to do their best into easing you into this thing. So you can pretty much bank on problem number 1 being probably the easiest problem of the entire exam. Here we go. Let us integrate from 0 to 1 a 4x cubed plus 2x. So, again, you can write on the exam. We expect you to write on the exam. Do your work. Now, this is multiple choice, so you don't have to show all your work, but you need to show it to yourself to make sure you don't make a stupid, careless error, because that will kill in this particular exam. Here we go. The integral from 0 to 1 of 4x cubed plus 2x. Well, integral of 4x cubed, 4 is a constant. Integral of x cubed is add 1 over add 1, x to the 4th over 4. Plus 2 is a constant. Integral of x is x squared over 2, evaluated from 0 to 1. Cleaning it up, notice your constants cancel nicely. So this is x to the 4 plus x squared, evaluated from 0 to 1. And now, according to the fundamental theorem of calculus, we plug in top minus plug in bottom. I get 1 to the 4th plus 1 squared minus, when I plug in 0, I end up getting 0. So what did you end up getting for this solution? Well, let's see here. 1 to the 4th is 1, plus 1 squared is 1, and 1 plus 1 is 2. So the answer is C, equal to 2. All right. When it comes to this stuff, you can always hear the careless errors out here, but the fact of the matter is, take your time. This is a 3-hour exam. That being the case, you've got plenty of time. Now, this first part, you've got up to an hour to complete. So there's some people going to finish this thing in 30 minutes, and that's fine. And you'll turn in part 1 in 30 minutes. That's fine. And then you go on to part 2 and part 3. But you got 3 hours. And if you want to be slow and meticulous, you got up to an hour. But after 1 hour, you have got to turn part 1 in, because we do not allow calculators for the first hour. So if you get part 2 and part 3, that's awesome, but you still can't use your calculator until everybody has completed part 1. That is the rule, making sure that it's fair, that some people have calculators, some people don't. It's too tough to keep up with. Nobody's allowed to use the calculators until everybody has turned in part 1. So take your time on this thing. It's not going to take that long. Usually part 1 has around between 13 to 15 or so questions. I think at most I've ever seen is 17, something like that. But it's around 15 questions you can bank on. So here we go. The integral from 1 to 2 of 4 over x squared dx. Well, another easy one. But remember this. Clean it up first. This is the 4 times integral of x to the negative 2 dx from 1 to 2. So you notice these are real nice ones, but in terms of integration and stuff, it is real nice in terms of, well, the bounds will be nice in terms of plug-in number. What's the integral of x to the negative 2? Add 1 over add 1. X to the negative 1 over negative 1 times 4, of course, out front, evaluated from 1 to 2. And now clean it up. This will be negative 4 over x, evaluated from 1 to 2. Fundamental theorem of calculus. Negative 4 over 2, plug in top, minus negative 4 over 1, plug in bottom. Again, no calculator, so take your time on this one. So here we go. Negative 4 over 2, that's equal to negative 2, minus negative 4 divided by 1 is a negative 4. And that gives you negative 2 plus 4, which is equal to 2. So once again, the answer is equal to 2. Answer is D. Does that make sense? If you came in late, just to remind some folks, this is the Calculus 2 review session being held in here. If you're in Calculus 1, the Calc 1 section is in Fretwell 100, just up the hall. All right. Problem number 3. Again, beating you guys to death on the integration. It didn't take them long before them having to use some kind of techniques of integration. What technique of integration would you use to integrate 2x over 1 plus x squared? U-sub. Remember, U-sub is the #1 technique of integration. Before you try any other technique, try U-sub first. It may work out for you. So I would let u equal to 1 plus x squared. That makes du equal to 2x dx. Cleaning it up, that means 1/2 of du equals an x dx, which is actually in the problem here. This is equal to 2 is a constant, it holds over. This is division. U's on the bottom. And the x dx gets replaced with a half du. And you'll notice the 2's end up canceling. So you end up getting basically 1 over u du. And what is the integral of 1 over u du? Natural log, officially, absolute value of u. No bounds on this one, so don't forget your plus c. So this is equal to the natural log of the absolute value of 1 plus x squared, close absolute value, plus c. Okay? So, which one is this one? Well, also notice this. When you take a number and square it, what do you get? What kind of number do you get when you take any number and square it? Positive. Add 1 is more positive. So honestly, the absolute values are meaningless. So they will typically drop the absolute values when they don't really are not very useful. And you'll notice that you get the answer is A. Does that make sense? Questions? All right. All right, now, so far, in terms of the exam, what I remember about last semester is folks did real well on the first few problems. It's right here when people started to fall apart. Why? Now you have to find the value of the integral from -1 to 2 of f of x dx, where f of x is a piecewise function. 2x if x is less than 1, 2 if x is greater than or equal to 1. So, how do I integrate this thing? I'm going from -1 to 2. But the integral from -1 to 2 of f of x dx, by definition, would be the integral from -1 to 1 of f of x dx, using my property of integral bounds, and plus the integral from 1 to 2 of f of x dx. I get to break up my bounds. But why did I choose to break it up at 1? Because that's where my piecewise function broke it up at. So now I'm integrating between -1 and 1, so those are values of x's that are actually less than 1. I get to use the 2x function. So now I got the individual function, the integral from -1 to 1 of 2x dx, plus the integral from 1 to 2 of f of x dx, and from 1 to 2, that's bigger than 1, I get to plug in for the function 2, the integral of 2 dx from 1 to 2. Now I'm going to do this, they're simple integrations, so I'm just going to do them both at the same time. Integral of 2x dx is x squared, evaluated from -1 to 1. Plus the integral of 2 dx is 2x, evaluated from 1 to 2. Fundamental theorem of calculus, plug in top, plug in bottom. This will be 1 squared minus -1 squared, plug in top minus plug in bottom, plus plug in top, 2 times 2 minus plug in bottom, 2 times 1. And at this point, it's just arithmetic. But here's the sad thing. Because this is a no calculator section, right here is where most students will screw it up. I mean, we've trained you well on all this calculus integral. You need to practice, of course. But now, here we go. 1 squared is 1. -1 squared is what? 1. Plus 2 times 2 is 4. Minus 2 times 1 is 2. So 1 minus 1 cancels. That's 0. And 4 minus 2 is 2. So if you guess 2 on all these problems, man, you're a really good guesser. But the answer is 2 once again. Does that make sense? That'll lose you guys anywhere. But notice how we integrate piecewise functions. Oh, you know you're in trouble when they start doing integral of trig and they got things like pi halves and pi fourths and pi thirds and no calculators. Remember that. So here, let's do this one. What's the integral of sine dx? Well, first off, you got to integrate sine and make sure you know what the integral is and make sure you know the sine of it. What's the integral of sine x dx? Negative cosine of x, evaluated from 0 to pi halves. This is equal to negative the cosine of pi halves minus negative the cosine of 0. Now we plug in our numbers here. This will be negative. What is the cosine of pi halves? Pi halves being 90 degrees straight up. Very good. 0. Things we are supposed to know from high school trig class. A minus is a plus. What is the cosine of 0? 1. So the answer is 1. So the answer is B. Does that make sense? Questions, complaints, comments? All right. Number 6. Let f of x be equal to the integral from 0 to x of e to the t to the 5th dt. We're supposed to find the derivative. This is what I call the second fundamental theorem of calculus. I think our textbook calls it the first one. But it's one of the fundamental theorem of calculuses. We're trying to take the derivative of an integral. So since the function is the integral from 0 to x of e to the t to the 5th dt, when I take the derivative, this is the whole idea of the concept of integration and anti-differentiation. The derivative of an integral, you don't go anywhere. Since I've got x on the bound, a single x, all I got to do is the derivative integral cancels and replace the t with an x. The answer is e to the x to the 5th. Which is answer, which one? Answer is E. I'm making sure you understand the theory and the theorem. Yeah? It's because it's the derivative. It's called the fundamental theorem of calculus. There's two parts. The fundamental theorem of calculus is when you integrate, you take the antiderivative, you plug in top, plug in bottom, get the area under the curve stuff. And the second fundamental theorem of calculus is the fundamental theorem of calculus when you take the derivative of the integral. So this is f prime. I'm taking the derivative of it. So really what I'm doing with f prime of x is I'm taking the derivative of the integral from 0 to x of e to the t to the 5th dt. And the derivative and the integral cancels, because that's the idea, so you just get the function out of it. All right? And what happened to the 0, if you think about it, if I actually integrated this thing, I plug in top minus plug in bottom, but 0 is a constant, and then you take the derivative of it, the derivative of a constant ends up being 0, so it doesn't matter what that constant is. When you take derivative of it, it ends up being 0. It didn't take long. Try number 7. I want you to integrate 0 to pi halves of x times the cosine of x dx. This is a guy you should recognize. We have beat him up all semester long in terms of problem recognition. Now you can use U-Substitution, but what would you let U equal to? I would let U equal cosine x, but there's no negative sine x waiting for this thing. So whatever I let U equal to, du's got to be in the problem. My only other option is let U equal x, but we know with U-Substitution, letting U equal x is stupid. So U-Substitution is not going to work for me. And you'll notice this is a product. It is x times the cosine of x dx. So what method of integration are you going to use on this thing? Integration by parts. So this is the integral of u dv equals uv minus the integral of v du. Formulas we have memorized. So here we go. In this particular problem, what would I let u equal to? Well, you want to let u equal to the part you want to get rid of. You can use your little Lytle thing, and you start off with the natural logs, and then the inverse trig, and eventually you let equal to the polynomial. But typically, my little English is a little better. I let u equal to the part I want to get rid of, and you get rid of things through the derivative. If I let u equal cosine of x, well, derivative cosine of x is negative sine of x. That doesn't go away. It just turns into a different trig function. However, if I let u equal x and I take derivative of it, what's derivative of x? 1 dx, and the x goes away. That forces dv to be equal to the cosine of x dx, so you have to integrate that to get v back again. What is the integral of cosine of x dx? That's positive sine of x. Now I'm going to plug it into my formula of u times v minus the integral of v du. This would end up being x times sine of x minus the integral of v, which is sine of x, du, which is dx. So I'm literally plugging it into my formula. U times v, x times sine of x, minus the integral of v, integral of sine x, du, which is dx. Now all I got to do with integration by parts is integrate the second term here. This is x times the sine of x minus, but what's the integral of sine x? What's the integral of sine x? Negative cosine of x. And with that negative makes it a what? Positive cosine of x. No plus c's on this thing because I got bounds from 0 to pi halves. So now I'm going to use my fundamental theorem stuff here and plug in top minus plug in bottom. I get pi halves times the sine of pi halves plus the cosine of pi halves minus, plug in bottom, plugging in 0, 0 times the sine of 0 plus the cosine of 0. Notice the wonderful use of parentheses here. And you'll also notice I got plenty of room to work this problem out. So let's see how good you guys are. What is the sine of pi halves? Sine of pi halves is 90 degrees, straight up. What's the sine of it? It's 1. What's the cosine of pi halves? That's 0. Sine of 0 is 0, but who cares? It's still being multiplied times 0, so that part's gone. What's cosine of 0? 1. So be careful. Watch the careless errors. So this will be parentheses pi halves times 1 plus 0 minus parentheses 1. And so what do I end up getting on this guy? I end up getting pi halves minus 1, which is answer E. Does that make sense? Questions, complaints, comments? All right. Yeah. Well, it's supposed to be on the on your Moodle page. You're supposed to have the 2013 one. If you want to, see me after class. I'll shoot you a copy, but it's kind of late now. Well, let's see what I do have. No, I only brought one copy for it. Well, that's not true. All right. I happen to bring the original from last semester's exam. If you want to share it with your friends, come up here and take it. And all I can say is Merry Christmas. Okay. All right. There you go. All right. Uh-oh, here we go. Take a look at problem number 8 here. Now remember, it's 3 parts, so I gave you, actually I only have one exam, so it literally had all 3 parts to it. So this is part number 1. Problem number 8. What is the Maclaurin series, i.e. the Taylor series, centered at 0 for this particular polynomial? F of x is equal to 1 divided by 1 minus x squared. All right. Well, there's lots of different ways you can go about doing this one and turning this thing into a series. But, I mean, you can just sit there and work on your derivatives and stuff, but you'll notice something or other. Whether I actually start taking the derivative of these things or actually use my power series representation for it, the whole goal is to turn this thing into a series. You will notice that this is in the form of a over 1 minus r. Right? So I'm trying to show you the easiest way to do this thing. Being it's a over 1 minus r, what's a going to be equal to? 1. What's r going to be equal to? X squared. So I can turn this thing into, remember, this is the power series representation. N goes from 0 to infinity of a r to the n. So this will turn into, the sum is n goes from 0 to infinity of a, which is 1, r, which is x squared, raised to the n. You want to clean that guy up, but a power to a power, what do you do with the powers? Multiply. So this ends up becoming the sum as n goes from 0 to infinity of x to the 2n. Now, just a note, it's not on the test, but I'm trying to review you guys for the final exam. What would the interval of convergence be? Interval of convergence. Well, the absolute value of r has to be what? Less than 1. So the absolute value of x squared has to be less than 1, but then you take the square root of both sides, you get the absolute value of x, which is less than 1, which makes negative 1, less than x, less than 1. And remember, when you do the power series representation to come up with the series, you don't have to test your endpoints. If you're trying to figure out the interval of convergence and use the ratio test, you actually have to test your endpoints. All right? But, look, that's not what they wrote down here. What did they write down here? They actually wrote out the series. So you need to write out the series. What does n start with? So let's write it out. N equals 0, n equals 1, n equals 2, n equals 3. I think we can catch a pattern here. N equals 0. 2 times 0 is 0. X to the 0 is 1. Plus 2 times 1 is 2. This will be x squared. Plus 2 times 2 is 4. That's x to the 4th. I think I caught my pattern. Seems to be the even guys. So it's 1 plus x squared plus x to the 4th plus x to the 6th, which is which answer? The answer is B. Absolutely. Absolutely. That's a beauty of power series. They're easy to manipulate. So, as we were just saying, if you happen to have the series 1 over 1 minus x memorized from its Maclaurin series, you can write that term out and replace all the x's with x squareds, and you're winning the game. Let's take a look at the next guy. Number 9. Well, this was mighty decent of them. They didn't have to do this. This is the integral of 4x dx divided by x minus 1 times x minus 5. They're trying to kind of throw it in your face what technique of integration you should use here. The denominator's factored. How do I know? They went and factored it for you. I can't promise they're going to do this on the next test. They could have easily given you the integral of 4 over, what is this, x squared minus 6x plus 5. Something like that. But when you're integrating something that's a fraction, proper fraction, notice the degree of the bottom is going to be 2, and the denominator factors, what technique of integration do we use? Partial fractions. So partial fractions, you're going to take the 4 over x minus 1 times x minus 5, and you're going to break it up over its little denominators, which is x minus 1 and x plus 5. And being these are degree 1, the numerators have to be a degree less, degree 0, which means they're going to be constants, a and b. Now, what I do next is I clear denominators. After I broke it up, I clear my denominators. I'm going to multiply by my common denominator of x minus 1 times x minus 5. And that's going to give me 4 is equal to a times, because when you multiply here, the entire denominator cancels, equals a, x minus 1 cancels, so I'm left with x minus 5, plus b, and the x minus 5 cancels, so I'm left with the factor of x minus 1. There's a pattern to this. But I taught my class, and I believe Desiree did the same thing with her class, the Annihilator Method. What am I going to do now? I got 2 letters to solve for, a and b. What am I going to do? I'm going to pick some values for x's. What values do you suggest I choose for x? 1 and 5. The annihilators, the ones that kill off my terms, the zeros of your factored polynomial. So here we go. Plug in x is 1. If I plug in 1, I get 4 is equal to a times 1 minus 5 plus b times 1 minus 1. Now, I did that for your benefit to show you the annihilator method. That 1 minus 1 is 0, and so that's going to go away here. That leaves me with 4 equals negative 4a. I divide both sides by negative 4, and I get a to be negative 1. Plug in 5. I get 4 is equal to, plugging in 5, a times 5 minus 5 plus b times 5 minus 1. And 5 minus 5 is 0, so I get 4 is equal to 5 minus 1 is 4b. That makes it real nice. Divide by 4. b equals positive 1. So, this turns my problem into the integral of, and what was a? Just make sure you put the letter over the right guy. A is negative 1. It goes over x minus 1. Plus b, b is 1, and that goes over x minus 5 dx. So this problem just turned into this guy. Whole purpose of partial fractions. And I can't emphasize enough the importance of partial fractions, especially in classes like differential equation stuff where they're going to beat this stuff to death. It's better to do calculus on easy stuff in little individual fractions than one big fraction. That's a technique you see a lot in DiffEq. All right, so here we go. Now, typically, if I'm going to integrate these guys, I'm going to use U-Substitution. I'm going to let U equal denominator. But I've also tried to teach my students the ability to do stuff in their head. This is U-Substitution in your head. If I let U equal x minus 1, then du equals dx. So that ends up becoming pretty much negative 1 over u, which ends up, when you integrate it, will be negative the natural log of, absolute value of, x minus 1, plus, same idea here, this is u, and du is dx, that's 1 over u, which ends up being the natural log, when you integrate it, natural log of x minus 5 plus c. So, which one is this one? Well, be careful now. Well, this guy is negative, so typically when we write stuff, we put the minus stuff in the back and the positive stuff in front. So this is the natural log of x minus 5 minus the natural log of the absolute value of x minus 1 plus c, which is c. Again, trying to prepare you guys for the final exam. They had every right to write the answer like this. Just a little side note. The answer could have also be written as the natural log of the absolute value of x minus 5 divided by x minus 1 plus c. They could have done that to me if they wanted to. Why? It's logarithms. What do you do with logs when you're subtracting them? What does subtraction turn into? Division. So this answer and this answer are equivalent, and they could have put one of those guys as my multiple choice answers. They love to play algebra with you guys. Does that make sense? All right. The geometric series of 1 plus a half plus a quarter plus an eighth plus a 16 converges to. Well, two things. Number one, it's a geometric series. You got that formula memorized. Your geometric series is this. The sum as n goes from 1 to infinity of a r to the n minus 1. I'll use the old form here. And that's equal to, it converges to the formula a over 1 minus r if the absolute value of r is less than 1, and diverges if the absolute value of r is greater than or equal to 1. Things we know from the geometric series. But here's the thing. They didn't write it out like this. They wrote it out piecemeal. They wrote out the series itself. 1 plus a half plus a quarter plus an eighth plus a 16. When they write out a geometric series, it's real easy to figure out who's A and who's R. A is the first guy written out. What's the first guy written out? What's your first term? 1. R is that ratio. It's what you have to multiply term to term to get to the next term. What do I need to multiply 1 by to get to a half? Half. What do I need to multiply a half by to get to a quarter? Half. What do I need to multiply a quarter by to get to an eighth? Half. That's your R value, is what you multiply by. So there, I've got it. So I know that the absolute value of R, which is still a half, is less than 1. So we know it converges to, and we knew it converged anyway because look at the way they wrote the answers. But it converges to the formula A over 1 minus R, which is 1 over 1 minus a half. 1 minus a half is a half. So this is equal to 1 divided by a half. And when you divide by a fraction, you invert and multiply, I get 2. So the answer is converges to 2. Does that make sense? So they love to give you these geometric series like this because they're real easy to identify, but you got to know some stuff to do it. Remember, I haven't used a calculator yet. Don't plan to, not until the next section. The area of the region in the first quadrant bounded by the curves y equals 3x squared and y equals the square root of x is equal to, and man, they went out of their way to say here is 0 is less than x is less than or equal to 1. They shouldn't have had to do that, but they did. That was awfully nice of them. Sometimes they'll give you some hints, sometimes they won't. So here's the deal. If I'm trying to find area between two curves, what's the first thing you're going to do? Graph it. Now, I don't have my graphing calculator. Well, you also have the third grade. We can graph this stuff without a graphing calculator. Let's take a look at this thing. Y equals 3x squared. What does that look like? Parabola. Y equals 3x squared. What does the equation y equals 3 times the square root of x? What does the square root of x graph look like? Well, it starts at the origin and bows out. Y equals 3 square root of x. So here's the region they're talking about, and it's in the first quadrant. Notice that. And you got to find your points of intersection. But it should be obvious because they even told you what they are. It's 0, and this point over here where these two guys are equal to each other, we can set them equal to each other and solve. So it's possible to do this without a calculator. But they even tell you, look, 1 squared times 3 is 3. Square root of 1 is 1 times 3 is 3. They're going to meet up over here at 1. And they tell you 0 to 1. So there you go. What is the formula for finding the area between two curves? There's two formulas. It's top minus bottom dx, and it's right minus left dy. These functions are in terms of x, and I have a distinct top bottom. So this would be the integral of the top minus bottom, because I'm going to go dx on this thing. My top function, what's on the top? 3 square root of x. Don't forget to use your parentheses there. Minus, what's my function on the bottom? That's the parabola, 3x squared. From my points of integration, or my bounds, are from 0 to 1. Now, let's clean it up. This is the integral from 0 to 1 of 3x to the half minus 3x squared dx. Because I don't do square roots. Square root's a half a power. Now you integrate. 3 is a constant. Integral of x to the 1 half. Add 1 over add 1. That's x to the 3 halves over 3 halves. Minus the integral of 3x squared is x cubed. It's x cubed over 3, but the 3's cancel. no bounds, no plus c because we have bounds, from 0 to 1. But now I'm going to clean this guy up one more time here. So I invert and multiply, so this will be 3 times 2/3. Notice the 3's cancel. X to the 3/2 minus x cubed, evaluated from 0 to 1. So this ends up becoming 2x to the 3/2 minus x cubed from 0 to 1. Notice I am taking my time on trying to clean up my algebra. Again, where most students will make a careless error. And there's no forgiveness in careless errors when it comes to multiple choice questions, so take your time. Fundamental theorem, plug in top minus plug in bottom. This will be 2 times 1 to the 3/2 minus 1 cubed minus, when I plug in 0, I pretty much get 0. 1 to any power, 1 to the 3/2 power is 1 times 2 is 2. Minus 1 cubed is 1. What is my answer? 1. The answer is E. Does that make sense? Take a look at this guy. The integral of the sine of x e to the negative cosine of x dx equals what? So another classic integral. The integral of the sine of x e to the negative cosine of x dx. What technique of integration are you going to use here? No. What's the major first technique you should always try before going off into the interesting world of biparts or partial fractions or whatever? U-substitution. What is the whole purpose of U-substitution? It is the idea that whatever I let u equal to, if I can take u equal to some kind of part of the problem, when I take its derivative, du up to a constant is also in the problem. This is a classic U-substitution problem. What would you let u equal to? Exponent on e's, negative cosine of x. Then you've got to take derivative. What is the derivative of negative cosine of x? Well, the derivative of cosine of x is negative sine of x. With that negative, makes it back to positive sine of x dx, which just so happens to be in your problem. Classic U-substitution. Okay? So now, I've turned this into an integral of e, and the negative cosine of x was the u, and the sine of x dx gets replaced with du. So it's a simple form. What's the integral of e to u du? E to the u, no bounds on this stuff, so plus c, and then I back substitute, which gives me e to the negative cosine of x plus c, and there's my solution. Which is answer, which one? Answer is D. Does that make sense? Take your time. That was a 10-second problem, literally. All right? Number 13. I want you to integrate 4x times the natural log of absolute value of x dx. Anytime you're integrating a natural log of something or other, you should always, one, try U-substitution. But if U-substitution doesn't work, what are you going to use? By parts. And usually when you integrate natural log stuff, it's going to be a by parts kind of problem. Unless U-substitution works. So I always try U first, U-substitution. Well, I can't let u equal x because that's stupid in U-substitution. But I can let u equal natural log of x, but the derivative of that's 1 over x. And there's no 1 over x dx in this problem. I can let u equal 4x, but that's just like u letting u equal x. So that's not really the game. And I have a product here. This is definitely a by parts. The integral of u dv equals uv minus the integral of v du. So here comes my second by parts problem. But you'll notice, basic rules, U-substitution, most important is U-substitution, and there's always going to be a few by parts on this exam. So make sure you know your by parts, and make sure you recognize, because we tend to use the same problems over and over again with you guys. So with this problem, integration by parts, I got to figure out what u is and dv. When you're integrating a natural log times somebody kind of a problem, and you're using integration by parts, you'll always let u equal to what? Always. Natural log. So let u equal to natural log absolute value of x. That forces dv to be the rest of it, which is the 4x dx. That's the whole problem there. Now I'm going to let du, what is the derivative of the natural log of x? 1 over x dx. And now I have to integrate. What is the integral of 4x dx? Well, let's add 1 over add 1. Clean it up. What do you get? 2x squared. Now we plug it into my formula. So this integral of 4x natural log absolute value of x dx turns into u times v minus integral of v du. Substitution. U times v looks better to write like this, though. 2x squared times natural log absolute value of x, u times v, minus the integral of v, 2x squared du, which is times 1 over x dx. I just wanted you to see that literal substitution. And let me show you right here. This is where students will screw this problem up. And usually we'll try to even kind of make this kind of one of our answers and type thing here. All you got to do is integrate this guy here. What's the integral of 2x squared? Well, that's 2x cubed over 3 times, what's the integral of 1 over x? Natural log of x. So they got 2x cubed over 3 times natural log of x when they integrated that thing. And they violated about 45 rules of math. They should be shot, but they're going to end up losing 5 points on the final exam because they're stupid. Why? You always do this first when you do integration by parts. You have to, once you do that u dv, you got to clean it up. There's no product rule for integration. Just don't integrate the parts and just kind of multiply it together. You have to clean it up. That's where most students will mess this kind of a question up. What is 2x squared times 1 over x? What is that? Right. So it cleans up nicely, and then integrate that. This integral of 2x dx. Now it's nice, and you can actually use the integral rule here. Minus, what is the integral of 2x? X squared. No bounds on this stuff, so plus c. So there's my answer. Which one of my answers is this guy? The answer is C. I tell my students this all the time. You know, when I'm taking a multiple choice test, I'm real good about getting the answer. But everybody has their own little quirks about where they're going to screw up a problem. Okay, I will lose a sign on occasion. My students will attest to that one on occasion. But where I mess up on a multiple choice test is I'll have the right answer, and then this is where I have to actually slow up. I have to actually analyze each individual answers because I'm real quick to circle something and move on, and I'll pick the wrong guy because the minus was a plus and I wasn't paying attention. So whatever your quirks are, take your time, identify what your specialty is and where your problems are, and slow down during your problem situation. This particular part, part 1 of the final exam had 15 questions. So here we go. Now this one right here is about as easy as we can make it if you actually know something or other. There's two ways of doing this problem. You can actually write out the Maclaurin Series. Now that takes some doing. Now I just want to remind you what the Maclaurin Series formula is. A function is equal to Maclaurin is centered at 0, f of 0, plus f prime of 0 over 1 factorial times x, plus f double prime of 0 over 2 factorial times x squared, plus f triple prime of 0 over 3 factorial times x cubed, plus dot, dot, dot. That is the Maclaurin series. It's a Taylor series centered at 0. And you should have known that. They shouldn't have to tell you that type of thing. However, which means I'm going to do a bunch of derivatives. Well, you can do that. That's just eating up some of your time. Now, you can do that to double check or whatever the case. Now, if you give you a hard function, they're going to want you to do this. But in this problem, that's not what they wanted you to do. This is part 1 of the exam. This is no calculator stuff. We're going to integrate and do the simple Maclaurin-Taylor series and power series representation stuff. This is what you really should have done. If I want a power series for e to the negative x, what I should do is just write down the power series of the ones I have memorized. What do you have memorized? The power series of e to the x. You remember there were 5 series you're supposed to have memorized. E to the x, let's see here, was 1 over 1 minus x. That was the cosine of x. It was the sine of x. And it was the arctangent of x. Those are the power series you're supposed to have memorized. And here's a classic one. E to the x. What's the power series for e to the x? Maclaurin series for e to the x. What is it? 1 plus x, officially over 1 factorial, plus x squared over 2 factorial, plus x cubed over 3 factorial, plus x to the 4th over 4 factorial, dot, dot, dot. There you go. Now, if you go and start taking your derivatives on this thing, you'll end up getting the right answer here. But it's so easy to do Maclaurin series or Taylor series because they're easy to manipulate. That's not my series. I want the series for e to the negative x. So what are you going to do? Replace all the x's with negative x. So this gives you 1 plus negative x over 1 factorial plus negative x squared over 2 factorial plus negative x cubed over 3 factorial plus negative x to the 4th over 4 factorial plus dot dot dot. Now clean it up. This gives me e to the x equals 1. This is negative x. That'll be minus x over 1 factorial, which is 1. Negative x squared. When you take a negative and square it, it becomes positive x squared over 2 factorial. When you take a negative 1 and cube it, it's back to negative x cubed over 3 factorial. You take a negative and raise it to the 4th power, that's plus x to the 4th over 4 factorial, dot, dot, dot. And now, I'm just trying to make it look like my answers. Let's see what you guys know about the old factorials, because they didn't write it with factorials, they wrote it with numbers. So this is 1 minus x. And what exactly is 1 factorial? 1 plus x squared divided by, what is 2 factorial? It's 2 times 1, which is 2, minus x cubed over, what is 3 factorial? 3 times 2 times 1, 6, plus x to the 4th, 4 factorial. 4 times 3 times 2 times 1, 24. So, which one of these guys is my answer? Take your time, but notice they're alternating. It's plus minus. So that's plus minus plus, take it out. It's answer A. Does that make sense? But don't get me wrong. I could sit there and take the function, the first derivative, second derivative, third derivative, fourth derivative, and plug in 0 and plug it into this formula, and I will get the exact same thing. But it's so much easier to manipulate your known series. Yes? Yes. Thank you. This is e to the negative x because that's what I'm plugging in. Thank you, dear. This was the power series for e to the negative x. This was my power series for e to the x, and then we plugged in for e to the negative x. So all these are the same, just cleaned up. All right, one more. And here's the problem right here that a lot of students messed up because they just started guessing at the answer because they didn't know what to do. And that was a shame. Because this is an integral that you were supposed to have memorized. Now, let me show you something rather. This is the multiple choice part of the test. We're not grading your work. But because I'm trying to do a review for the final exam, I'm going to show you the proper techniques of work just in case this problem happens to show up on the free response part, which we are grading your work. Does that make sense? So, what kind of integral is this guy? Now, well, granted, I'm talking about the type of integral first. I'm integrating from 0, hint, 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 to infinity of 1 over 1 plus x squared. What do you call that? Improper integral. So if I wanted to show my work on how to do this one, you got to turn the improper integral into a proper integral. It's all about the work. It's the same idea as when I used the integral test on some kind of series or something or other. You had to show your work. This is the limit. Pick your favorite letter. We're all shooting for A's in this class. Limit as a approaches infinity of the integral from 0 to a of 1 over 1 plus x squared dx. Proper technique is everything. We do take off points if you don't put the limit and you just give me a number. We'll actually not give you credit if you just chunk down a number without showing how you got that number. And we are looking for how you write this stuff up on the free response part. What's the integral of 1 over 1 plus x squared? That's a rule you have memorized. Limit as a approaches infinity. What's the integral of 1 over 1 plus x squared? Arctangent of x. That's not U-Substitution or anything. It's a strict formula you have memorized. With bounds from 0 to a. Fundamental theorem of calculus, plug in top minus plug in bottom, but you have to keep writing that limit as a approaches infinity of the arctangent of a minus the arctangent of 0. And remember, there's no calculator on this section. I don't have the ability to actually use this. If I don't know it, I'm in trouble. What is the arctangent of 0? The tangent of what is 0? 0. In other words, remember it's sine over cosine. It's sine over cosine of what angle is equal to 0? Well, the sine of what angle equals 0? Well, that's 0. Now, So this turns into the limit as a approaches infinity of the arctangent of a. Plug in infinity. What is the arctangent of infinity? In other words, what angle, when I take the tangent of it, it blows up to infinity. I get the old does not exist on the old calculator. Think about your graph. What is it? It's something you're supposed to have memorized, by the way. And just a little side note, and I'll write it over here. The arctangent of infinity is what? Pi halves. Oh, sorry, got off the page there. Arctangent of infinity is pi halves. That was one of those limit laws we were supposed to have memorized. So when I plug in infinity here, it's arctangent of infinity, which is pi halves. But honestly, we should have written the answer like this. Because it was an improper integral, we shouldn't have written the words converges to pi halves. That lets me know it's also an improper integral. But the real answer to this problem was B. That's what they were after, pi halves. All right. You will notice that I am finished with part 1. How long did it take me to finish up part 1? Well, I actually talked a little bit about the exam and stuff like that. So I got started a little bit late setting up all the programming stuff. So it honestly took me about 45 minutes. And here's the sad thing. I explained every problem to you guys. If I didn't have to explain it, I can cut out about 30 minutes of my time with you people and actually get it in about 15 minutes. But I've done this kind of stuff before. You are a little bit newer at it, but you're still supposed to do exactly what I do. My point is this. Most folks finish part 1 in around 30 minutes or so. Sometimes it'll take you a little bit more, maybe 45 minutes. But how long do you have for part 1? 1 hour. Okay? So now it's part 2. But let's say I still got 15 more minutes before my hour's up, and I'm still not allowed to use my calculator. Don't sit there like some of my students have done before in the past. Sit there and just have part 2 and part 3 in front of them and just sit there and wait. What are you waiting for? You can do most of part 2 without a calculator. And if you need a calculator, we'll stop to that point, skip over it, move to the next problem, and then go back and finish it up. Because you will not be allowed to use your calculator for the first hour of the exam, but I've still got time to go. So here we go. And again, the other thing that you guys should be doing as we are doing this exam and looking at other older exams, you noticed on my Moodle site for my students, I pushed old exams on there with old videos that I covered the material and stuff. You should be going through this thing and also writing down formulas that you're supposed to have memorized. Here's a classic one. All right? People got freaked out on this first one, just to let you know. Read the question. Let f be a monotonically increasing continuous function on the interval between 1 and 5. Choose the values at integer points that are shown below in the table. So also let I equal the integral from 1 to 5 of f of x dx. Choose the correct statement. I is going to be between 30 and 50, between 18 and 26. I has got to be greater than 26, between 2 and 9. I is going to be less than 0. People looked at this thing and didn't know what to do. That's a shame. Because you should know exactly what to do. If they give you a table and they are telling you I is an integral of somebody, and they gave you a table, they didn't give you the function, let me remind you, they gave you a table and they want you to talk about integrating it. What do you do when you're integrating numerical values off of a table? What technique of integration do we use since we don't have the function, but we got a table of the values? Riemann sums. This is a Riemann sum problem. So, we're supposed to estimate what I happens to be. I is the integral from 1 to 5. So if you want to, you can sit there and kind of draw this thing out. This was not necessary though. This is 1, 2, 3, 4, 5. And at 1 we got 2 value. At 2 we got 3. At 3 we got 6. 4, 5, 6. At 4 I got 7. And at 5 I got 10. 8, 9, 10. And this just shows you that it was a monotonically increasing function. It looks something like that. And we're supposed to, here's the deal, I'm trying to figure out I. I is the integral from 1 to 5 of f of x dx. You guys have been programmed since day one of this class. When I'm trying to do some kind of visual representation of the integral, what is it? Area under the curve. When you integrate with bounds, you're calculating the area under the curve. So we want to figure out the area under this curve. That's what I is going to be. The area under the curve. But look at the answers. They want you to figure out it's bounded between I is between 30 and 50, 18 and 26. Maybe it's above 26, between 2 and 9. So basically they want me to bound the integral. And it's a chart. There's a clue. It's a chart. I'm trying to drum this into your head. When you're integrating a chart, you're going to use Riemann sums. And so this is the smallest Riemann sum type of thing here. This would be like the biggest. How do you figure out the smallest and biggest Riemann sums? Left and right Riemann sums. That's what you're supposed to do in this problem. So we're going to do the left Riemann sum. So just to remind you, Riemann sums. So I'm going to do the left Riemann sum. Remember your formula. It's the sum of f of x times delta x. And I'm going to use left endpoints. What is delta x going to be in this problem? Delta x is the change in the x values. Look at your chart. I'm going from 1 to 2, from 2 to 3, from 3 to 4, from 4 to 5. What's my change? Delta x is 1. I'm changing by 1 each time. Does that make sense? Delta x is 1. You can do b minus a over the number of partitions. You can do that, but it's easier to look at it. I'm going from 1 to 2, 2 to 3. Delta x is 1. So this will be the sum of, I'm using left Riemann sums. Left Riemann sums, these are my partitions. This is why I drew it out for you guys. So I'm going to use the points on the left. That would be f of 1 plus f of 2. This is my first interval. This is my second one. My third one, the point on the left is f of 3. And then my last one, my point on the left is f of 4. And it's all times my delta x, which is 1. Now, what is f of 1 equal to? F of 1 is 2. Plus f of 2 is 3. Plus f of 3 is 6. Plus f of 4 is 7. All that times 1. I don't think I need a calculator for this. Let's see here. 2 plus 3 plus 6 plus 7. Well, 3 and 7 make 10. 2 and 6 makes 8. What is that? 18. So my left Riemann sum is 18. Just to show you, you actually should be able to look at the answer at this point, but let's just do the right Riemann sum. The right Riemann sum is the sum of f of x delta x. That would be using the right endpoints for each partition. So here's my first partition between 1 and 2. The point on the right is 2. So this will be f of 2 plus the next partition. The point on the right is f of 3. Plus between 3 and 4, the point on the right is f of 4. Plus between 4 and 5, the point on the right is 5. So it would be plus f of 5 times the delta x part, which is 1. So this would be equal to f of 2, which is 3 plus 6 plus 7 plus 10 times 1. Well, I think we can do some more work here. Let's see here. 3 and 7 is 10, plus another 10 is 20, plus 6 is 26 times 1 is 26. So the right Riemann sum is 26. And because this was monotonically increasing, going up, the left Riemann sum is going to be an underestimate, and the right Riemann sum is going to be an overestimate, which means I has to be less than or equal to, 18. The left Riemann sum has got to be less than or equal to I, which is less than or equal to the right Riemann sum, which is 26, which makes my answer B. Does that make sense? A lot of students looked at this question, and here's the thing, and there's nothing more frustrating than this. And when this happens to you on part 2, and you haven't even gotten to the hard stuff yet on part 3, people get frustrated. They looked at this problem, didn't know what to do. They didn't have a clue what to do. And the sad thing is, they should have. How many web work problems have you guys done this semester? About 400, right? Yeah, about a lot. Absolutely. This is Calculus 2. We make you eat web work in this class. I understand that. Eat, sleep, drink. You love web work. You should, because this is what gets your grade in this class. But that being said, look at the question. Every time we did a Riemann sum problem, we either gave you some awful function, but more likely on web work, we gave you a chart. So if they give you a chart of values on a problem, think Riemann. There's a clue. Does that make sense? Questions, complaints, comments? All right. Take a look at number 2. Uh-oh, here comes one of those series problems again. All right, so here we go. And we did a problem very much like this on my review session as well as some problems in class. So let's take a look at this one. They love to give these kind of problems with you because this is the kind of problem where you have to go through each answer. Choose the correct statement. Sum as n goes from 1 to infinity of 1 over n squared converges, and the sum of n goes from 1 to infinity of 1 over n cubed diverges. We'll look at each problem and figure out if it's true or false. What kind of series is that, guy? P is equal to what? What does it do? Well, that's right. What is that one? P series P equals 3. What does it do? That's wrong. That says it diverges. So A is wrong. So I'll go to the next one. What series is this guy? What does the harmonic series do? Well, that's just wrong, so that can't be the answer either. Didn't even look at this thing over here because it didn't care. Well, yeah, it is 1 over n cubed and P is 3. It does converge. That's true, but that's false there, so the whole thing's false. Look at the next one. 1 over n squared. That's a P series again. P equals 2. That converges. What's this one? Harmonic series. What does harmonic series do? It diverges. Well, this is true. This is true. That must be the answer. Answer C. Well, wait a minute. We better look at the rest of them because people don't believe me. All right, 1 over n squared. That's P series. P equals 2 what? That converges. It says it diverges. That's a harmonic series. That diverges, so that's good. But that's sorry, that's just wrong. And what about this one? P series P equals 2. It converges. They said it diverges. That's just wrong. And that's a harmonic series. That actually diverges. That's just wrong. That's just wrong all around. So the answer is only one to C. But notice you had to go through each statement. That's what you have to do with these kind of problems. All right. Problem number 3 here. Find the arc length. Uh-oh, another formula you better have memorized for this exam. What is the arc length formula? So to try to help you guys out, there are 3 arc length formulas you're supposed to have memorized. What is it? Arc length is equal to the integral of the square root of 1 plus f prime of x squared dx from a to b. It's also equal to the integral of the square root of 1 plus f prime of y squared dy, okay, from c to d. And arc length is also equal to the integral from a to b of the square root of dx dt squared plus dy dt squared dt. This is the formula when you have a parametric equations. X equals something in terms of t, y equals something in terms of t. This is when x is equal to a function in terms of y. And we use this one for arc length when y equals something in terms of x. Depends on what your variable is. dx, x is independent. dy, y is independent. dt, t is independent on your parametric equations. Okay? So, what do we got here? We got the easy kind. We got y equals 2/3 x to the 3/2. So, that would use, because my function's in terms of x, this is my guy right here. So my arc length would be equal to, but to do the arc length, I got to have the derivative of this guy. What is the derivative of 2/3 x to the 3/2? Well, 2/3 is a constant, leave it out front. The derivative of x to 3/2 is bring down 3/2, x, and subtract 1. 1/2. This cancels. I get x to the 1/2. There's my derivative. It cleaned up nicely. So the arc length is the integral of the square root of 1 plus the derivative x to the 1/2 squared dx over your bounds. What are my bounds? Well, I'm doing dx. So my bounds are my x coordinates. I even told you what the x coordinates were. What are they? Between 3 to 8. 3 to 8. Clean it up before you integrate it. Arc length is equal to the integral from 3 to 8 of the square root of 1 plus... A half of power is a square root, but when you square it, they cancel out, you just get x. Power to a power, you multiply. dx. Now, because I'm trying to practice, and this is on the calculator section, and maybe by this time I'm allowed to use my calculator, but maybe not. I can do this problem without a calculator. So this problem could have shown up in the no calculator section. Let's see if we can do it without a calculator here. So here we go. If I'm going to integrate this thing, what technique of integration would you use? U-Substitution. What would you let U equal to? Inside parentheses, 1 plus x. That makes du equal derivative of 1 is 0, derivative of x is 1 dx. So this turns into the integral of u to the 1/2, because I don't do square roots, du. What's the integral of u to the half? Add 1 over add 1. That'll be u to the 3/2 over 3/2. Better yet, that becomes 2/3 u to the 3/2, which becomes 2/3 u was 1 plus x to the 3/2. We got bounds from 3 to 8. And again, I'm doing this for your review of trying to do the algebra, because this is stuff you should be able to do without a calculator. Fundamental theorem of calculus, plug in top minus plug in bottom. So I get 2/3 times 1 plus 8 to the 3/2 power minus 2/3 times 1 plus 3 to the 3/2 power. Fundamental theorem of calculus, plug in top number, plug in bottom number, getting that quote-unquote area under curve stuff here. All right, so let's see here. This is 2/3. Let's see, 1 plus 8 is 9 to the 3/2 power minus 2/3 times 4 to the 3/2 power. Just a note, 3/2 power, what does that mean? Well, 3 is in the numerator, that's your power. Halves, that's a half in the exponent there, a half, but the 2's in the denominator, that means it's a square root. So, I'm going to take the square root of 9. What's the square root of 9? 3, and then cube it. What is 3 cubed? 27. So this is 2/3 times 27 minus 2/3. 3/2 power. A half is a square root. Square root of 4 is 2. Cubed is 8. So this gives me 2 times 27 is 54 thirds minus 2 times 8 is 16 thirds. And what is 54 minus 16? 38 thirds. And there's my answer. And notice, Mom, no hands, no calculators. Impressive. The fact is, the answer is D. You didn't need a calculator for this problem, just to show you guys. And they reserved the right to give you this kind of a problem on the non-calculator section. But they were nice giving a calculator section. So honestly, now that it's on the calculator section, now I've got, like I said, it's on the calculator section. Make sure to double check your answers. Even though I'm pretty good about my arithmetic here, I'm going to go math number 9 just to double check. I'm integrating from 3 to 8 of the square root of 1 plus x dx. And then I go math fraction it. And there it is, 38 thirds. Okay? My point is, even though I was trying to help you guys practice for the exam, showing you the algebra, because that's where most students will screw this stuff up at, with this kind of a problem, it's on the calculator section. Use your calculator. Double check your answer. Problem number 4. Oh, here's some of your favorite. Back to Riemann sums again. You've seen these guys. So here we go. The definite integral from 0 to pi halves of the sine of x dx equals what? They want you to take this here integral and turn it into a Riemann sum, which means you got to know your Riemann sum formulas. First thing is this. Delta x is equal to b minus a divided by n. Second thing is this. xi is going to be a plus I times delta x. And the third thing is that the Riemann sum, a true Riemann, is going to be the limit as n approaches infinity of the sum as I goes from 1 to n of f of xi times delta x. There is your Riemann sum formula with the parts. On this particular problem here, it's the integral from 0 to pi halves of the sine of x dx. That tells me a is equal to 0, b is equal to pi halves, and my function that I'm trying to integrate is the sine of x. I read that off right up here. Does that make sense? A is 0, b is pi halves, and the function sine of x. So now, first thing I'm going to do is calculate delta x. b minus a over n, that would be pi halves minus 0 divided by n. So that's pi halves over n, which is pi over 2n when you clean it up. xi by formula is a plus I times delta x. A is 0 plus I times delta x. But delta x we just discovered was pi over 2n. Now I'm going to plug it into my formula down here. My formula is this limit as n approaches infinity of the sum as I goes from 1 to n of f of xi delta x. This will be the limit as n approaches infinity of the sum as I goes from 1 to n of f of xi. Let's talk about that for a second. F of xi would be the sine of xi. But xi is actually I pi over 2n. So I'm going to replace xi with I pi over 2n. That would give me the sine of I pi divided by 2n times delta x. Delta x is times pi over 2n. It's f of xi times delta x, just to let you know what I'm trying to plug into this thing. So this is my answer. Which one of these guys is it? And take your time on it. Be careful. This is where I would screw this problem up, so I have to look at every different answer. And I believe the answer that I got here is B. But notice, they put their pi over 2n out front. That's designed to mess you up. Sine of I pi over 2n, sine of I pi over 2n. A lot of folks chose D, but what's the problem with D? The pi, there should need to be a pi up here. It's supposed to be pi over 2n. This has got the pi over 2n. What's wrong with this guy? You don't have the 2n in the denominator. You've got to be very careful on these kind of problems. The answer is B. Does that make sense? Again, what am I also trying to show you guys as you're studying for this thing? The formulas you're expected to have memorized. Riemann sums. Questions? Problem number 5. Which of the following integrals is 0 for arbitrary a greater than 0? Again, here's a problem that students just didn't know what to do about. Because they're coming up with questions to try to separate A students from B students, B students from C students, C students from the D students, and the D students from the people that don't have a clue. So, they're trying to figure out, okay, first off, the integral is 0. So the integral is 0. Now, this goes back to the idea of area under the curve. Okay? So if I got an integral that's 0, that means I got to have half my area above the x-axis and half my area below the x-axis. So what I'm going to do here is I'm actually going to try to figure out which one of these problems is going to give me an answer of 0. An integral of 0, which means my area is going to cancel. So what I'm going to do here, the trick to this problem was graph the functions. So this will be y equals cosine of x. What does the cosine graph look like? Well, at 0, you're at 1, so it looks something like this. It's a smiley face. From 0 to 2 pi, it looks like this. Well, we're going from a over here to negative a. We're integrating from negative a to a. So I got to do this reverse imaging over here. Looks something like this. Now, if I look between a and negative a, okay, and maybe, depending on where a is at, a could have been over here, like negative a is here, a is over here. Is this going to give me, guaranteed, every time an area of 0? Not if a is right there. That's a positive area there. It's when I pull it back. If it's right here, give me area 0. If I go back over something like over here, it's not going to give me an area of 0, because if I could have made it from here to here. Remember, a can move. That's my point. I'm trying to move my a's here. A is here, a is here, a is over here. I'm always going to get an area of 0. No. Graph this guy. Well, same function, but this time it's the cosine of x, which looks like this, between 0 and a. Will this always be an integral of 0, regardless of what a is? No, there's some positive area right there. It's clearly not 0, so this is definitely not the answer either. Let's graph the sine function. What does the sine function look like? Sine function, so this is y equals sine of x here, starts at the origin, goes up, comes back down, and back again. Is this going to be always 0? Well, if I put my a right here, here's 0 from 0 to a. That's, again, more positive area. This is not going to be my answer. What is the integral? What is the graph of x sine x? So y equals x sine x. Let's take a look at that guy. Again, we're going from negative a to a, so I'm going to do arbitrary negative a's over here, and positive A is over here. But now I'm going to start using my calculator. Now that I've got the calculator section here, I'm going to graph x sine x. And I'm going to check my mode, make sure I'm in radian mode, which I'm not because I've been doing some physics for people. Now it's in radian mode here. So second quit, y equals, and I'm going to hit zoom 6 on it. What does this graph look like? It's symmetric. It looks like this. Looks something like that. When I integrate from between negative A and positive A, again, we're talking about area under the curve. Is that always going to give me 0? No, I got some positive area between those two guys. So the answer, this one's not. So clearly the answer is E, but I better show you why. So let's graph this one. Y equals x cosine of x. So I'm going to go up here to my y equals and change my x sine x to x cosine of x. And I'm going to graph it now. And when I graph this guy, I get this picture. What do you see? It is symmetric with respect to the origin. Let's see if I can do this. Comes up here and does this. Okay, this is my bad handwriting on a graph, but this is what I see. Does that make sense? If I go between, I don't care where you put an A here. Put an A over here, but equal but opposite. Put a negative A over here. If I integrate this thing, you'll notice that I'm trying to get area captured between the graphs. I get this little spot. But then over here I get this spot, and this little spot. These two little spots are going to cancel. One's above and one's below. This spot and this spot cancel because one's above, one's below. This spot and this spot cancel because one's above, one's below. So when you're going between negative A and positive A, is your answer always going to be 0 because the area above is always going to cancel with the area below? Yep. The answer for this guy is 0 because this is an odd graph now. That's why E is the answer. But the trick was, all you had to do was think about area under the curve and graph these guys and think for all A, regardless of A, is it going to work between negative A and A or between 0 and A? So you had to draw it out. All right, let's take a look at this next guy. Problem number 6. If the integral between 0 and A of 5x to the 4th dx equals 32, then what does A have to be? Here's a classic algebra integration problem. So, all I'm going to do is integrate. So the integral between 0 and A of 5x to the 4th dx is going to be, what's the integral of 5x to the 4th? X to the 5th, right? X to the 5th over 5, which 5's cancel. Evaluated from 0 to A. According to the fundamental theorems, you plug in top, A to the 5th, minus plug in bottom, 0 to the 5th. And what's that supposed to be equal to? 32. Well, a 0 to the 5th is 0, so that just gives me A to the 5th equals 32. And then all I have to do is take the 5th root of both sides. So what is the 5th root of 32? What times what times what times what times what is 32? 2. So the answer is E2. Questions, complaints, comments? All right. We have a series. Woohoo! All right. So, given the series, look at the question. Now, I discussed on our review day about this particular question, and this should really haunt you with the words that I used. Take a look at this thing. I've got the sum as n goes from 1 to infinity of negative 1 to the n over n cubed. What am I supposed to do? To figure out what you're supposed to do, you have to read the answers. It is divergent. It is absolutely convergent. It converges but not absolute, called conditional convergent. Only has a finite number of terms. It's equal to 0. They put this problem on several old final exams. There's 2 of these questions that are just stupid as all get out. Which 2 answers are stupid? D and E. Why are D and E stupid? Number 1, this is called an infinite series. See that big old infinity up there? That means it has more than a finite number of terms. That's just stupid. Equals to 0? No, this is a series. We're trying to figure out if it converges or diverges. And this is some kind of interesting series here. I can't tell you exactly what it converges to, so that's definitely going to be the answer. But look at the question. The question really is with part B. Remember, when they start asking for absolute convergent, it's either absolute convergent, conditional convergent, convergent but not absolute, or it diverges. So when you do these kind of problems, you start with number one. You check for absolute convergence, because that's your big kind of convergence. If it's absolute convergence, it converges regardless if it's alternating or not. Absolute convergence, you take your series, and you take the absolute value of it. And what does the absolute value do? The whole purpose of the absolute value is to get rid of the alternation, the negative 1 to the n. Because the absolute value of negative 1 is 1. So this turns into the sum as n goes from 1 to infinity of 1 over n cubed. Now you need to identify this series. What's the name of this series? It's a P series. What's P equal to? 3. What does it do? Converges. And so it converges because it's a P series, P equals 3, that which makes this original problem with the alternation part absolutely convergent, because when you hit the absolute value, it's still converged. The answer is C. Oh, sorry, B. Thank you. There's me doing that again. Right. I saw the word absolutely, and I just had to circle it. I'm sorry, but it converges absolutely. The answer is B then. But does that make sense, though? The idea of, now here's the deal. If it failed to be absolutely convergent, then what do? You test for conditional convergence by going after, because now you put the alternation back on there, and you use the alternating series to see if it, by using the alternating series test, if it converges that way, it'll be called conditional convergent, convergent but not absolute. If it failed that, well, there's only one other answer. It had to diverge. Problem number 8. A particle moving along a straight line has this velocity. V of t is equal to 3t squared plus 1 feet per second. Is the velocity of the particle at time t measured in seconds. Suppose that the particle is located at a point x when t equals 0. So x of 0 would be equal to 0. When time equals 0, the function is equal to 0. All right? Find the distance in feet from the point x as a function of time. Okay? From the point x equals 0. All right. Well, here's the deal. What is this whole problem about? Well, they gave me velocity, and what do they want? They want distance. Distance, position. Right. How do I go from velocity to get to distance? So, to get your distance formula, which they're calling x of t, all I've got to do is integrate. Integral of 3t squared plus 1 dt. Well, integrate it. Well, this gives me x of t would be equal to integral of 3t squared. Well, integral 3 is a constant. Leave it alone. I'll just do this. The integral of t squared is t cubed over 3, and 3's cancel. Plus, what's the integral of 1 dt? T plus c. Because you integrated, you've got to have a plus c, because there's no bounds on this thing. Which gives me this. X of t is equal to t cubed plus t plus c. But how do I figure out what c is? Well, they tell me right here, position when time equals 0 was what? X was 0. So x of 0 would be 0 cubed plus 0 plus c, and that's supposed to be equal to 0, which forces c to be 0. Therefore, your position vector, your distance vector, is x of t equals t cubed plus t. Which is, which one of these answers? The answer is D. Does that make sense? Classic physics application. They gave you velocity. They wanted distance. You integrate velocity to get distance. Oh, good. Spring problem. Finally getting to some physics here. A particle is moving along a straight line with a straight horizontal line by a force F depending only on the location of the particle. That right there throws so many people off because they don't know what to do. What? They're describing you a force. Yay. Let x represent the distance from the particle to the origin measured in meters, and let F equal 3x squared in newtons. Find the work done by the force when the particle is moved from a point x equals 0 to a point x equals 2. Recall that 1 joule is also known as 1 newton meter. Okay. What do they want me to do? Go look at all this stuff and find the question. Here's your question right there. Find work. The first, after we did the area between two curves and the volume rotation stuff, the first formula that we came up with work was this. Work is equal to the integral of force dx from A to B. That's how we came up with our formula for pumping stuff out of a tank, lifting baby Jessica out of a well, all those kind of problems that we did. What's force equal to? They gave me the force, what was it? 3x squared, and they want to find the work, so the real question is this. Find work when between x equals 0 to x equals 2. So what am I going to do? Well, first, and again, what threw a lot of people off because they put this kind of in word problem format here, but they're asking you to find work. They gave you a force function, and you want to find the work between 0 and 2. So work would be equal to the integral between 0 and 2 of 3x squared dx. So, integrate it. What's the integral of 3x squared? Do you need a calculator for that one? I don't think so. What is it? X cubed, evaluated from 0 to 2. Fundamental theorem, plug in top minus plug in bottom. 2 cubed minus 0 cubed. And 2 cubed is 8. 0 cubed is 0. So what do I get? 8 joules. What's my answer? E. As long as you knew the formula, this is free points. But you'll be amazed how many people looked at that one and going, I don't know what to do. Well, look for a question. Find work. And remember your work formulas. All right, here's a chapter 5 question here. If the integral between 0 and 1 of f of x dx is 5, and the integral between 1 and 5 of f of x dx is 2, then what's the integral between 0 and 5? Yeah, pretty much. But the integral between 0 and 5, I got to put my pieces together. Sometimes you have to subtract them, sometimes you have to add them. So I'm trying to go from 0, so I'm going to start at 0, but I know this. It's the integral from 0 to 1 of f of x dx, plus I integrate it from 1 to 5 of f of x dx. Because this is basically using your integration properties. I'm trying to integrate from 0 to 5 so I can break it up anywhere. Integral from 0 to 1 plus the integral from 1 to 5 is actually the integral from 0 to 5. But we know what this guy is. This was 5. Plus the integral from 1 to 5 was actually 2. So my total answer is 7. Answer is A. It's multiple choice. All right, all wrong. Right. Well, no, free response. I mean, multiple choice, no. Part 3, we do get partial credit for. The free response, we're grading your work. This one's just grading your answers on the multiple choice questions. Let's take a look at number 11. Again, here's a great problem that just people did not know what to do. So, given an integral between a and b of f of x dx, the quantity s equals b minus a over 6 times f of a plus 4f of a plus b over 2 plus f of b is the Simpson approximation. They took your classic Simpsons rule and they played some algebra with it. Don't freak out. This is the Simpsons rule that they want you to use. They're trying to help you out. All right. This is your Simpson approximation for using two subintervals, two partitions, if you will. Which of the following, here's your question, which of the following integrals coincide with their approximations obtained by the Simpsons method that uses the two subintervals? Here a equals 0 and b equals 1. In other words, again, I think it was the English that threw people off. They didn't know what to do. Which of the following integrals coincides? That word right there messed people up. What does the word coincide with their approximations? Better word for that would have been equal to. Coincides means equal to. We want to know which one of these integrals, that when I integrate it by hand and get an answer, and when I use Riemann sums with two subintervals, I get an answer. Which one of these integrals is actually going to give me the same thing as the Riemann sum? which is going to quote-unquote coincide. That word coincide killed people. They didn't know what coincide meant. Okay, well, too late. You can't use your cell phones to go look up that word on the thesaurus or anything. Sorry. Coincide means it's got to be equivalent to or equal to. So, here we go. Let's practice each one of these guys. So, let's integrate these guys. Now, I think I can integrate these things in my head, but you have your calculators because this is the calculator section here. What's the integral of x squared? X cubed over 3. Plug in top minus plug in bottom. Plug in 1 minus plug in 0. What am I going to get? Well, integral of x squared is what? X cubed over 3. When I plug in 1, 1 cubed is 1 over 3 is 1/3. What is the integral of x cubed dx? What's the integral of x cubed? X to the 4th over 4. Plug in top minus plug in bottom. Plug in 1 minus plug in 0. What am I going to get? All right, guys are catching the pattern. Good deal. Now, plug in x to the 4th. Integrate it from 0 to 1. That'll be x to the 5th over 5. From 0 to 1, plug in top minus plug in bottom. I'm going to get 1/5. These are my answers for the integrals. So here we go. For the function f of x, which is equal to x squared, I'm going to plug it into my Simpsons formula. Remember, a is 0, b is 1. For every one of these problems, a is 0, b is 1, my function is going to change. So this would, the Simpsons rule, would correspond to 1 minus 0 over 6 times f of 0 plus 4 times f of b plus a. 1, that'll be, I'm doing this for your benefit, 1 plus 0 divided by 2 plus f of b, which is 1. All I did was take this guy right here and plug in a is 0 and b is 1 all the way throughout my formula. Let's clean them up. So my Simpsons rule would be 1/6 times f of 0 plus 4 times f of 1/2 plus f of 1. Now here I go. I'm going to go plug in my numbers. This is just for the x squared, but you'll catch a pattern quickly. This will be 1/6 times, what's f of 0? Remember, f of x is x squared. What's f of 0? 0 squared, which is 0, plus 4 times, what is a half squared? What's a half squared? Times 1/4, plus, what is 1 squared? 1. Now, crunch me a number. 4 times a 4th is 1. 1 plus 1 is 2. So this gives me 2/6, which is equal to what? 1/3. So when f of x equals x squared, and I use their Simpsons rule for 2 subinterval formula, I get 1/3. What was the original integral? 1/3. So a checks. It coincides with actually its integral. Does that make sense? Now, put my little dotted line right here. Now I'm going to do f of x equals, what's my next guy? X cubed. This is what they wanted you to do. So now I'm going to do my Simpsons rule here. S would be equal to, but notice my formula is going to be the exact same. This is still going to be 1/6 times f of 0 plus 4 times f of 1/2 plus f of 1. What do you get when you crunch this out? This is 1/6 times 0 cubed is 0 plus 4 times a half cubed is an 1/8 plus 1 cubed is 1. So what do we got here? What's 4 times an 1/8? 4 goes to 8 how many times? 2 times, so it's 1/2 plus 1, that's 3/2. So it's 3/2 times 1/6. So I got 3/2 times 1/6. So 3 goes into 6 3 times, so I end up getting what? 3 goes into 6 2 times, so I end up getting 1/4. My question is this. Does this coincide with the integral from 0 to 1 of x cubed dx? Yes, it does. I got 1/4 again. So I got 1/4, and we got 1/4 up here, so B also checks. I got 1/3 here when I integrated. I got 1/3 over here, so A checks. So it's maybe the last one. Maybe all three of them are going to work. So now let's do this one. F of x equals, what's this one? X to the fourth. Again, my Simpsons rule hasn't changed. It's 1/6 plus f of 0 plus 4 times f of a half plus f of 1. This would be equal to 1/6 times 0 to the fourth is 0 plus 4 times, what's a half to the fourth? A half times a half times a half times a half. What is that? 1/16, isn't it? Right? Plus f of 1 is 1. So, 4 goes into 16 4 times, so this is a fourth. So this is going to be 1/6 times, let's see here, that's a fourth plus 1, that's 1 1/4, which is 5/4. This gives me 5 over 24, something like that. Let's just double check what that number is. 5 divided by 24. I got 0.20833333. Does that coincide with 1/5? 1/5, by the way, is actually just 0.2. Are they the same thing? They do not coincide. They are not equal. So what is my answer? A and B only. The answer is C. This was a problem that people just cried about, and they didn't understand what the word coincide, meaning equal. Good. All right, let's take a look at number 12. Number 12, there's a couple different ways you can do this guy. The question asks you to find the interval of convergence of the power series. Well, there's two ways I could have done this problem, and I'll do both ways, and then you guys decide which way you like better. Well, the first way that I taught my students is this. Anytime you need to find the interval of convergence of a power series, what are you going to use? Well, then we can do that. Ratio test. That'll give you the answer. But there was a little easier way, but we'll talk about that in a second. So I'm going to use the ratio test on this thing. I'm going to take the limit as n approaches infinity of the absolute value of an plus 1, which is x to the n plus 1, over 5 times n plus 1 plus 2, over x to the n over 5 to the n plus 2. Now, this is equal to, clean it up, invert and multiply. This is the limit as n approaches infinity of the absolute value of x to the n plus 1 divided by 5 to the n plus 1 plus 2 is actually n plus 3 if you think about it, cleaning up my numbers there. I invert and multiply, so this is going to be flipped up. This will be 5 to the n plus 2 there. And when I flip it up, x to the n stows up on the bottom. So here we go. Now, I got 5 to the n plus 2 on top. I got 5 to the n plus 3 on the bottom. Which one has more? The one on the bottom. How many more does it have? Pull off 1. That gives me 5 to the n plus 2. And that cancels with that guy. X to the n plus 1 over x to the n. Well, x to the n plus 1 is actually x times x to the n. So x to the n's cancel. This leaves me with the absolute value of x divided by 5 when you clean them up. When does the ratio test converge? So it's the absolute value of x over 5. The L part has to be less than 1, which tells me negative 1 is less than x, which is less, x over 5, which is less than 1, solving my double-sided inequality. Now I'm going to multiply by 5 on all sides, and that's going to give me what? Negative 5 is less than x, which is less than 5. And there's my answer. But because I used a ratio test, officially I need to check the endpoints. Endpoints. X is equal to negative 5. And my other endpoint over here is x equals 5. When I plug in x is negative 5 into this thing here, I'm going to get the sum as n goes from 1 to infinity of negative 5 to the n over 5 to the n plus 2. Clean him up. And I'll blow it up so you guys can see it in the back here. Blow him up. And now clean them up here. This is the sum as n goes from 1 to infinity of negative 1 to the n, 5 to the n divided by, this is 5 to the n plus 2, and I'm trying to cancel some stuff out. That'll be 5 squared times 5 to the n. These guys cancel. This leaves me with the series n goes from 1 to infinity of negative 1 to the n over 5 squared. 5 squared, by the way, is 25, in case you want to know. What kind of series is this guy? Alternating series. So we're going to use the alternating series test. But with the alternating series test, you've got to use the Bn part. The Bn is the part without the alternation. It is 1 over 5 squared, which is 1 over 25. There's no n in this thing. That's going to be a problem. Because I'm going to use the alternating series test. Remember, the terms have to go down. But when I plug in n as 1, there's no n in sight, so I just get 1 over 25, 1 over 25, 1 over 25. It doesn't go down. That's a problem. Oh, by the way, you also need to take the limit as n approaches infinity. What's n approaches infinity of 1 over 25? 1 over 25. It doesn't equal 0, which means it does not converge. Fails the alternating series test, not convergent here. It diverges. Now if I plug in n as 5, check this endpoint. I get the sum as n goes from 1 to infinity of, remember, you're plugging n as 5 into x right here. There's my x. So that'll be 5 to the n over 5 to the n plus 2. But when you clean them up, the n's end up canceling. This is 5 to the n over 5 to the n times 5 squared. They cancel. You get the same series as we always said before, except one side alternates, one side doesn't. This is 1 over infinity of 1 over 25. Two ways you can tell this out. First off, by observation. What's 1 over 25 plus 1 over 25 plus 1 over 25 plus 1 over 25 an infinite number of times? It's going to eventually blow up to infinity. Also, I can use the divergence test. The divergence test says if I take the limit as n approaches infinity of the sequence part, 1 over 25, I get 1 over 25, which is not 0. And when you don't get 0, it diverges. So this thing is also going to diverge. So I don't want this guy either. So this is my interval convergence between negative 5 and 5. So the answer is B. But honestly, once you got this and started looking at your answers, you figure out they didn't include any of the endpoints on this stuff. You kind of could have figured it out from that too, but I should have done this. The reality is that this is actually a geometric series type because there's nothing but powers of n. Because of that, I could have used my geometric series formula and done this. Just a little side note. If you got nothing but numbers or variables to powers of n, it's a geometric series. I could have done this. This will be the sum as n goes from 1 to infinity. I can pull off 1x, and that'll be x to the n minus 1. I can pull off 3 5s, 5 cubed, and that'll be 5 to the n minus 1. That gives me the sum as n goes from 1 to infinity of x over 125 times x over 5 to the n minus 1. What is your r value in this geometric series? R value is x over 5. And now we know that being it's x over 5, the absolute value of r has to be less than 1, which gives me negative 1 is less than x over 5, which is less than 1, which gives me negative 5 is less than x less than 5. I get the same answer as before, but knowing it's a geometric series, the endpoints will never converge, so I don't have to check endpoints on. Absolutely, absolutely. That's kind of the point, that because it didn't have anything extra added onto it. The ratio test handles those really hard stuff, but if it's got powers of n, it'll do it too, but you have to check your endpoints. You do not have to check endpoints on geometric series, because with the geometric series, the r is going to be strictly less than 1, and you don't have to check your endpoints. So, but with the ratio test, you always have to check your endpoints. Well, then we got part number 3 here. Now is where you really need to be meticulous in showing your work. I still got a good hour or so. The way the exam is designed, You're supposed to take at most 1 hour to do the multiple choice, no calculator, 1 hour to do the multiple choice with the calculator, and 1 hour to do the free response. There's your 3 hours total. But usually the multiple choice won't take quite as long, which adds on more time on the free response. But remember, we're not just grading the answer. The answer's 2. I got 2. I should get full credit. But if you don't show me the work on how you got 2, we give you 0 points. We do give partial credit. We do give partial credit. If you screw up some kind of arithmetic towards the end, but you had all the work done properly, you're going to get some major points for that. We do look at work. We're going to be focusing on your work, not just the answer. So, let's start with question number 1. Question number 1 asks you what? And again, what does it say right at the beginning? You must show all your work to receive full credit here. So, first question. In the half plane, x greater than or equal to 0, the region defined by R is defined as one of the bounded by the curve y equals 5x minus x squared from above, and the curve y equals x cubed minus x from below. So they tried to draw this region out. You should graph it, because the first thing they want you to do, and they're going to make you do this in parts, part A, B, and C. We've got to find the points of intersection. But you've got to see this thing first. So I'm going to graph this guy. I've got y equals 5x minus x squared, and I got y equals x cubed minus x. So I'm going to use my old handy-dandy calculator here just to make sure I get a good graph, because you are allowed to use your calculators on this particular part of the test. So this is 5x minus x squared, and the other equation is x cubed minus x. Now I'm going to hit zoom 6 on this thing. And here we go. One, I got an upside down parabola coming right in here. Having this really cool color graph thing is really helpful. And I've got the other graph is the x cubed minus x, which kind of comes in here. I'm exaggerating a little bit here. But because I'm exaggerating it because I don't care about this, because they did say x was greater than or equal to 0, right? So we're really talking about what region? The one in the between the first and the fourth quadrant on the right half of the graph. And we're talking about capture between these two curves. So there we go. Does that make sense? But now, so I want my region here. And just to let you know, this is the upside down parabola, which this is 5x minus x squared. So this actually identifies the top part of the region. And this graph right here is y equals x cubed minus x. But now, so I've got my picture of what's going on here. And I should label it properly. Here's your y-axis. Here's your x-axis. And yes, we even gave points if you drew this thing out. All right. So now, but here's the deal. A lot of folks lost credit on this first one. Find the x-coordinates of the intersection points on this thing. What are you supposed to do? And granted, show your work. I had a number of people sitting there and going, oh, no problem here, Liz. You'll second calculate intersection, first curve, second curve. Looks like the origin's pretty much one of them there, and I think the other point's right about there. And yep, it's 0.26 actually. So there it is right there. I got the 0.26, and this is pretty obvious. It's 0, 0. So they just went ahead and put the answer 0, 0, and the 0.26. And okay, so this was just 3 out of the 10 points or whatever. How many points you got? 0. You didn't show your work. How do you show your work on getting points of intersection? This is what we're after. Set them equal to each other. So I got y equals 5x minus x squared. I got y equals x cubed minus x. So that gives me 5x minus x squared equals x cubed minus x. Being a polynomial type, I'm going to set everything equal to 0, so I'm going to subtract 5x from both sides, combining like terms, and I'm going to add x squared to both sides. This cancels. That gives me 0 is equal to x cubed plus x squared minus what? What is 1x minus 5x? What's your careless errors? Minus 6x. Always factor out what's in common here. What do I have in common? X, factor it out, leaves me with x squared plus x minus 6, Cleaning it up, I think they were nice to us, so we can actually factor this guy. How does x squared plus x minus 6 factor? It factors into x and x. What times what? It's 6, which differs by 1. It's got to be 3 and 2. Double check your signs here. Since I have a minus, one's plus, one's minus, the bigger one's going to be plus. Plus 3 minus 2. Then I set each factor equal to 0. And then I get x equals 0. I get x equals negative 3. And I get x equals 2. But yeah, now you're up to 2 points if you showed all this one. But get the third point out of this thing is this. Which points do they want? What did they tell me? X's had to be greater than or equal to 0. They only wanted this half of the graph is what I didn't really kind of care about what was graphing over here off my calculator. I mean, I got a better picture on the calculator here, granted. But I'm saying I don't care about this part because they only wanted x is greater than 0. X is negative 3 is actually somewhere over on this side. I don't care about him. I only want the x is greater than 0. So the real answer is x is 0 and x is 2. Absolutely. Don't have a problem with checking it on the calculator. But using the calculator and that's how I came up with my answer, that's not going to fly on the final exam, especially on the free response. Show your work. All right. Set up the integral for the area. Well, how do I find area? Well, since my functions are in terms of x, so therefore I'm going to do the classic area is equal to the integral from a to b of what I call the top function minus the bottom function dx. Just reminding you your formula. If I had a distinct right and a distinct left part of my function, then I would integrate right minus left dy. Does that make sense? But this picture, I have a distinct top and bottom. Just be careful. What's on top, what's on bottom. This is the integral. What's on top is this equation here, which is my parabola. 5x minus x squared. Minus what's on bottom is the cubic graph of x cubed minus x dx from a to b, 0 to 2. Again, we're looking not just for the work, but making sure you're writing down proper notation. This is an integral. I have bounds of my points of intersection, and it's top minus bottom. Now, you had to show your work to show this guy. So, now, but look at the question. We set up the integral. We would have accepted this answer. We would have also accepted if you cleaned them up, because the next one's going to be evaluate to find the area. So, this would have been the integral from 0 to 2 of 5x minus x squared minus x cubed plus x dx. We would have accepted this if you distributed the negative, but more likely you would have, if you did all that, you might as well combine like terms. What is x, 5x plus x? 6x minus x squared minus x cubed dx. We would have also accepted this answer. Does that make sense? But read the directions. Set up the integral. Now, but you understand what they're doing here. They're doing basically giving you the parts here. Find the points of intersection. Set up the integral and then evaluate the integral. And so there's 3 points, 3 points, 4 points for getting the answer. I think it was 3 points, 4 points, and 3 points for crunching it out. But here's again, you know, a lot of people lost 3 points on this problem. You know what they did? They went over here and went, oh, math, number 9. They went 0 to 2 of 6x minus x squared minus x cubed dx. 5.33333. Oh, I even give them do this for them. I'm a decent guy. 16 thirds. And they wrote down this answer right here, 16 thirds. And they lost points. Why? What you got to do? Show your work. Now I'm going to use this guy because I'm definitely going to clean this guy up. So this is the integral from 0 to 2 of 6x minus x squared minus x cubed dx, which would be 3x squared minus x cubed over 3 minus x to the 4th over 4, evaluated from 0 to 2. This would be equal to 3 times 2 squared minus 2 cubed over 3 minus 2 to the 4th over 4 minus 0, and oh, that's 16/3. There you go. But don't forget this. Very good. You asked to find area. Units squared. If they ask you to find volume, what you going to put? Units cubed, unless they actually give you the units. But you had to show your work. Does that make sense? It was an area problem. They won't square. Take a look at this next guy. Because you know this is going to be on your test. In the first quadrant, x is greater than or equal to 0, y is greater than or equal to 0, and the region is bounded by the curves y equals 2 square root of x, y equals 0, x equals 1. Quote, Part A, set up the integral for computing the volume of the solid obtained by rotating the region R about the x-axis. First thing you should do, draw a picture. So, here we go. I got y equals 2 square root of x. I got y equals 0 and x equals 1. Well, I don't really need my calculator for this one. This one isn't too bad. 2 square roots of x starts at the origin, kind of bows out. So there's y equals 2 square root of x. Y equals 0 is also known as the x-axis. Y equals 0. I also have the line x equals 1. So here's 1 right here. So here's the vertical line, x equals 1. So we're talking about this region right here. Now, what we want to do is set up the region because we want to rotate about the x-axis. My function is in terms of x. So you understand where my question is coming from. My function is in terms of x. And they want me to rotate around the x-axis. What method am I going to use? Disk washer. So this would be volume equals pi times integral of big functional radius squared minus little functional radius squared. Since I'm going around the x-axis, that's going to be a dx from A to B. So setting up this thing, volume equals pi times integral. Now my big radius is from the axis of rotation to the outside edge. So my big radius ends up becoming 2 square roots of x minus 0, which is actually 2 square root of x. So I'm going to get 2 square root of x squared minus my inner radius. My inner radius, because I'm trying to rotate around the x-axis, actually end up making this thing solid. My inner radius has got to be 0. So minus officially 0 squared dx from, what are my bounds? 0 to 1. There's the origin, 0 to 1. So we clean this guy up. Volume equals pi times integral from 0 to 1 of 2 times the square root of x squared dx. We would have accepted this. And for those people that just bothers them to set up an integral but not actually compute it, we would have also accepted this, but anything else we didn't really care about. Volume equals pi times integral. What is 2 squared? 4. What's the square root of x squared? X dx from 0 to 1. We would have also accepted this answer. But that's all they wanted. Does that make sense? To remind you of your formulas. Disk washer versus shell method. This is clearly a disk washer method because I got function in terms of x going around the x-axis. Yes, ma'am. Because you got the outer radius is from the axis of rotation to the outside edge. The little r is from the axis of rotation to the inside edge, but the inside edge is on the axis of rotation. So it's pretty much 0 minus 0. And also, if you draw out what this thing looks like in terms of a region, it's this part rotated. There's no inner part that's being taken away. So the little r is actually from the disk washer method. It's from the washer part where you're actually having parts removed. Nothing's removed because this thing is solid when you rotate it. All right, take a look at the next guy. Same region. They love to do this to you guys. Now, same region. Find the volume of the solid by rotating the region R about the x-axis. Express your answer as in terms of multiples of pi here. So, part B was to take this guy, volume equals pi times integral from 0 to 1 of 2 square root of x squared dx, and actually evaluate it. But be careful. So, clean them up. This will be pi times integral from 0 to 1 of 4x dx. This is pi times the integral of 4x is 2x squared. X squared over 2, 2 goes into 4 2 times. Evaluated from 0 to 1. I would clean that up a little bit. That is 2 pi x squared from 0 to 1. This is 2 pi times 1 squared minus 2 pi times 0 squared. So what do I end up getting when I clean this stuff up? 2 pi what? Right. Because it's volume. And you found the volume of this guy here as this region is being rotated around the x-axis. So people were pretty happy with problems 1 and 2. You got down to problem number 3, and it scared them. All right, because there's that series stuff again, which I tell you is going to be about 25% of your final exam. That's why you've got to know this stuff. For each of the series below, determine whether the series converges or diverges. In each case, state explicitly which convergence test and or theorem, which theorem you are using. Right there. So, now remember the question. The question is, does it converge or diverge? They're not asking me, if it converges, find its sum. They never said that. So I'm either going to say the word is going to be convergent or divergent. So I got a 50-50 shot on each one of these problems. The problem is this. You've got to tell me what theorem you're using. Because if you told me the correct answer and you didn't state what theorem or what test you were using, 0. No points on that part. First one. What kind of problem is this, guy? What kind of series is that? Outstanding. It is a geometric series. You should know that by observation. Geometric series. Why is it a geometric series? Because it's got nothing but numbers raised to powers of n. So you can actually write this thing out if you want to, as the sum as n goes from 1 to infinity of 1/2 times 1/2 to the n minus 1. You can actually show that it's the geometric series. You really need to state the r value was actually a half. Because here's the deal. This is the part you had to show. You had to tell me what r was. Since the absolute value of r, which is the absolute value of a half, is less than 1, what's this geometric series going to do? It's going to converge. We actually know that it's going to converge to a over 1 minus r, but the answer is this. This is convergent by, and we were using the geometric series. We actually state the series that we were using. And we showed my work. Look at number or letter B. What's this series going to do? What is the sum as n goes from 1 to infinity of -1 to the n? Well, there's two ways you could have done this one. We would have accepted either one. I think most folks did this one. They said they were going to use we accepted AST. Because we as professors know what that means. What is that? Alternating series test. I got -1 to the n. But what is it going to do? Well, if you're going to use the alternating series test, you've got to show me the test. Well, then the Bn part's going to be what? What's the part attached to the -1 to the n? Right, it's 1. There's not much there, but you always have a constant 1 times everybody. And so we're going to test my series here. 1, 2, 3. I plug in n as 1, but there's nothing to plug in for. I get 1, 1, 1. There's a problem. It's not going down, is it? It's pretty much staying the same. And number 2, take the limit as n approaches infinity of 1. What you going to get? 1, which is not equal to 0, which tells me it does what? Diverges. So we would have accepted the answer diverges. Diverges by the alternating series test. But you actually had to show you're using the alternating series test. Yeah, we would have accepted that. However, there was another answer you could have used. You could have also stated divergence by the divergence test. we would have accepted that even though this was alternating. When you take the limit as n approaches infinity, it doesn't go to 0, so it doesn't go down. So we would have accepted that, but this would have been a better answer. This is the one we were looking for. Yeah? As long as you showed this part right here, we were real happy. But the theorem has two parts. The terms have to go down, and the limit has to go to 0. But here's the deal. If the terms don't go down, the probability is the limit won't go to 0. So, yeah, but you really want to kind of go out of your way. You're trying to pick up every point possible. Don't skip over anything and assuming they're going to give you credit for that. Other questions? Yes? You could have used the ratio test for this guy here. Would have been a lot harder, but it was supposed to be obvious that it was a geometric series because it's nothing but a number power of n. Use a ratio test when they're kind of more meteor. You got powers of n and or factorials and combinations thereof. That's kind of when it's done. But yes, we would have also accepted ratio tests. So understand what we're saying here. There's more than one there's only one answer, but there's more than one test you could have used. The answer is this thing converges. You could have used a ratio test on this one. That would have been a little more detailed work, but you could have used that. Or it was supposed to be obvious it was a geometric series, so you could have used, hey, this thing's a geometric series. And since R was 1/2, it converges. You got to state more reason why. If we used a ratio test on this thing, you got to give me the L value and show L was 1/2 and it would be less than 1. Okay? What about this guy here? Well, okay, so you stride over here. P series. P is equal to what? 5. Therefore, what does it do? Well, P equals 5. What does it do? Converges. So the answer is converges, P series, P equals 5. That's what we were looking for. What's that now? Well, sure, here you go. But I think we know that. Okay. That one, we would have accepted this. I mean, if you didn't show me that 5 was bigger than 1, we would. We are in Calculus 2. We're above the 2nd grade now, so we're good. What about D? What would you do on D? There's lots of different answers. Personally, I would have used this. Well, question first. You got a question on the last one? Yeah. Yes, you should always state what P is. If you state it's a P series, tell me who P is so it's obvious that we're comparing it to 1. So yes. So for these kind of questions, they don't care about absolute convergence? They didn't ask that. Again, it was in the directions. Because, again, does the series converge or diverge right here? But don't get me wrong, if they change the wording up on the exam and says absolute convergent, then they'll give you a bunch of alternating series, and then you end up doing that for the 3 steps. Check for absolute convergence. If that fails, check for conditional convergence by checking the alternating series test. And if that fails, it's going to diverge. This one right here, we would have accepted 2 answers. The first one would have been the easiest way. I look at this thing, and I would have done this. Well, shoot. The limit as n approaches infinity of 2n plus n squared is infinity. And the last time I checked, that was strictly bigger than 0. Which means by the divergence test, this series diverges. So I would put diverges by divergence test. And that would have been perfectly acceptable because it was supposed to be pretty obvious. But you know what? A lot of folks, because this is calculus class and just not happy unless they integrate something or other, you definitely could have used the integral test. And we would also accept the integral test. But here's the deal. If I use the integral test, what do I have to show? And this is important. Watch this. Because students lost a point on an easy problem, because they should have done that. But integral test. This would have been the integral from 1 to infinity of 2x, change into x's, plus x squared dx. You with me? But what kind of integral is this guy since you're using an integral test? It's the improper integral. you better start writing down proper notation here, because you got to show me the integral. Take the limit as your favorite letter a goes to infinity of the integral from 1 to a of 2x plus x squared dx. This gives you the limit as a approaches infinity of x squared plus x cubed over 3, evaluated from 1 to a. Where this would be equal to the limit as a approaches infinity of a squared plus a cubed over 3 minus, when I plug in 1, that's 1 plus a third, was that 4/3? And then, now plug in infinity. What's infinity squared? What's infinity cubed? What's divided by 3? Still infinity. Infinity plus infinity is a big old infinity. Minus 4/3, which means it's infinity, which means it's divergent. But you had to show all the integral steps to do this one. But now that I did that, we would also accept diverges by integral test. There was more than one test you could have used, which makes grading this thing painful, but there's still the only one answer. It was divergent. You could use either test. Does that make sense? Yeah. Well, see, for the divergence test, the series had to be all positive terms. So since the sequence part of your series had to be all positive terms, so you've got to get 0 if it has a chance of converging, because the divergence test can't tell you anything if it goes to 0. But as long as it doesn't go to 0, infinity is clearly not 0, it's bigger than 0, it's going to diverge. If it went to any number, let's say the limit went to 14. Well, it's not 0, therefore by the divergence test, the series would have diverged. All right, I tried to help you guys out with this kind of a problem by putting one like these on my test, which you guys just recently took. Look at how this is why you love the series. Now, this first problem right here was free points if you have it memorized. If you didn't have it memorized, you could have derived it. You need to know your Taylor series and your Maclaurin series formula. Make sure you have those things memorized, because they love to throw one at you that you have to derive on your own. But this one was trying to show the power of these series and the ability to have them being manipulated. Write down the Maclaurin series expansion for the function f of x equals e to the x. Well, what is the Maclaurin series formula for e to the x? 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus ... which would also be equal to the sum as n goes from 0 to infinity of x to the n over n factorial. This is the series formula for it. This is the formula written out.
Did you have to put the second part?
On this problem, no, you did not. The reason why you did not is they just said write down the Maclaurin series expansion for e to the x. If they said write down the series formula, then that's that guy. If they just say write down the series, all you can do is you can write down the terms and you can get away with that. We accepted both answers. We were just tickled to death when a student came up with this. Out of the 2,000 students, maybe 10 did this, but most folks wrote that, and we accepted it. Now, here's the whole point. Use part A to obtain a power series for e to the negative x cubed. So e to the negative x cubed would be 1 plus negative x cubed plus negative x cubed over 2 factorial plus negative x cubed cubed over 3 factorial plus negative x cubed to the 4th over 4 factorial plus ... which is also the sum as n goes from 0 to infinity of negative x cubed to the n over n factorial. But they wanted you to clean it up because you're going to be using it on the next one, so this is really the answer we were looking for. E to the negative x cubed is actually 1 minus x cubed plus, that's a square there, that's a little typo thing there, plus x squared, there's a 3 there, hold on, Got to put x cubes in there, and I got to square it. Cube squared, what do I do? Power to a power, what do you do with powers? That'll be 6. Over 2 factorial. Negative cubed is back to negative. X cubed cubed is x to the 9th over 3 factorial. Negative to the 4th power is back to positive. X cubed to the 4th power to a power multiply x to the 12th over 4 factorial. Plus dot dot dot. Which would be equal to, when you cleaned up the series formula, and I'm showing you this just in case they change their mind on this exam and make you guys write out the formula series. Negative 1 to the n, x to the 3n over n factorial. Now, this was a typo on the test, so they wanted this, and we had to go back and tell people, for part C, just integrate it, all right, and then part D, you're supposed to actually use it with the powers, okay? So, here we go. So for this guy, I want you to integrate e to the negative x cubed dx by using your series. So you could integrate 1 minus x cubed plus x to the 6th over 2 factorial minus x to the 9th over 3 factorial plus x to the 12th over 4 factorial plus dot 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 dx, which would also be the same as the integral from sum as n goes from 0 to infinity of negative 1 to the n, x to the 3n over n factorial. So now, but this is the answer we're looking for, the integral of e to the negative x cubed dx is equal to, what's the integral of 1? X. Minus what's the integral of x cubed? X to the 4th over 4. Plus what's the integral of x to the 6th? X to the 7 over 7 times 2 factorial. Minus integral x to the 9th is x to the 10th over 10 times 3 factorial. Plus integral x to the 12th is x to the 13th over 13 times 4 factorial. But what did you forget to write? There's no bounds in this thing. Plus c. And I usually put my plus c's in the front note with this type of stuff. And you got the plus dot dot dot.
We took the series out to 4 powers up top. Would they tell us how many, or is that just standard?
Standard 3 or 4. As long as you can catch the pattern, once we can see that you caught a pattern 3 or 4, you're good. Yeah, in part D, they're actually going to limit you because they're going to actually use that for part 3. So for these guys, 4, 5, we're real happy. All right, now, but I want to show you how to integrate the formula. Remember, when you integrate a series, the series is going to stay the same, integral from 0 to infinity. Now, we're integrating with respect to x here, so it's a dx here. So negative 1 to the n is a constant, leave it alone. What's the integral x to the 3n? We add 1 over add 1. This will be x to the 3n plus 1 over 3n plus 1. And your n factorial is a constant because you're integrating the x's. But don't forget, you also got the plus c out front. So this would be the integral of the series. Just all I'm doing is applying my formula to this stuff, and notice how clean it writes up. But now, part D is actually, you get to use this thing, because now you're going to integrate between 0 and 1 of e to the negative x cubed dx. And you got to use the first 3 terms. So this would be the integral from 0 to 1 because it's got bounds. I don't care about the plus c. I'm going to integrate for the first 3 terms. Officially it's this, x cubed plus x to the 6th over 2 factorial dx, the first 3 terms. And then, well, I just integrated this. This was x minus x to the 4th over 4 plus x to the 7th over 7 times 2 factorial. Evaluated from 0 to 1. They wanted bound 0 to 1. Showing my work at all levels here. This would be 1 minus 1 to the 4th over 4 plus 1 to the 7th over 7 times 2 factorial. Minus when I plug in 0 was nice. I got 0. And so this was equal to 1 minus 1/4. 2 factorial is 2 times 7 is 14 plus 1/14. And I end up getting, for you decimal fans, we accepted 0.82142855714. Or for you TI-89 fans, 23 over 28, because it probably gave you as a fraction. We would have accepted either one. But that's what we wanted to see. But of course, no work is no credit. You had to show me all this stuff. Does that make sense? Yeah. What happened? 1 factorial? Oh yeah, 1 factorial is 1. Okay. So whether you write it or not, we're happy. And we got number 5. Make sure you have these formulas memorized. Simpsons Rule, trapezoidal rule, midpoint rule, and all the error-bound formulas thereof. Because, once again, they happen to give you guys the error-bound formulas, but I can't guarantee that. You may have to have them memorized. They will ask about error bounds and they don't give them to you. It means you're expected to know them. All right. How nice, they actually wrote down the Simpsons Rule for 4 terms, which was kind of sad because you were supposed to memorize that one. So we told them, you don't need to write that down. Okay. So next time, they may not give it to you. Make sure you have these formulas memorized. All right. Well, this is calculus 2. Memorize everything. Did you guys learn that from like day 1 in this class? Have you guys memorized a lot in this class? Yes. All right. We've done our job then. All right. So, this isn't physics. We don't have little cheat sheets out here. We have to use our brains in calculus. All right. So here we go. Use Simpson's rule to approximate S4. And they gave us the formula. Now, they went ahead and integrated it for you, so you know the answer is 45 natural log of 5. But they said they wanted you to find S4 on this thing. So, but you got to know your formulas. What's delta x equal to? B minus A over n, which would be 5 minus 1. That's my B is 5, A is 1, over n, but they want S4, so n is what? 4. So, 5 minus 1 is 4 over 4, which is equal to 1. Delta x is 1. Now, I always write out my terms because I'm starting at 1. And I'm going out to, let's see here, my delta x is 1, so add 1, that would be 2, 3, 4, 5. 1, 2, 3, 4 partitions. So these are my endpoints for my partition. So to calculate S4, it'll be delta x, which is 1 over 3, times f of 1, plus 4 times f of 2, plus 2 times f of 3, plus 4 times f of 4, plus f of 5. Remember, it's your endpoints plus 4 times this guy, plus 2 times this guy, plus 4 times this guy, and you always end on a 4 until your endpoint. But what's my function on this thing? What are we trying to integrate? 45 over x. Showing my work, this would be equal to 1/3 times 45 over x is 1, plus 4 times 45 over 2, plus 2 times 45 over 3, plus 4 times, my function is 45, we're plugging in 4, plus 45 over 5. And this is equal to, when I put on my calculator, I got 73. This is what we were looking for. But I work real hard with my students, and I know Desiree has done the same with hers, in terms of these formula memorization. Who am I kidding myself? They're asking me on a final exam to do a Simpsons Rule problem? Cool. Y equals, clear out the old stuff here. What's my function? 45 divided by x. Second quick, go to my programs. Go down here to the old Riemann Sum program. What was my A in this problem? What was my B? 5. What is my n? Now, the n for the problem is 4. What n do I need to plug into my program because it doubles my n? You should plug in 2 because, remember, Simpson's Rule for the program doubles the n value. Hit enter, and how did I do? For twice n, so 2 times 2 is for 4n, Simpson's Rule for 4, what do we get? 73. Good check. Does that make sense? Don't forget your program on the calculator. Make sure it's working fine. All right. So, this was nice of them. They gave me an upper bound for the error in Simpson's Rule that's given by the error-bound formula is less than or equal to k times b minus a to the fifth over 180 n to the fourth, where k is the maximum value of the fourth derivative. Well, we should have known all that and had it memorized, because I can't guarantee, because they've had final exams before where they had to make you guys write this formula out. Yeah?
Doesn't the Simpsons Rule have to be even? Doesn't the Simpsons Rule have to be even?
Yes, it does. But notice n was 4, so we're good to go. So yes, Simpson's Rule, when you're using Simpson's Rule, the n value must always be even. So, but Simpson's Rule for 4 subinterval, 4 is even, so this works in Simpson's Rule quite nicely. But when I plugged in 2, the Simpson's Rule on the program doubles the n value. So when I plug in 2 here, all right, it actually gave me, let me just do it again. What was it, 1, 5. When I plug in 2, the Simpson's Rule doubles it, so it's guaranteed to be even now, but 2 times 2 is 4. So this is the Simpson's Rule for 4. The answer is not going to be even. The number of subintervals will have to be even. Sorry, let me explain that. The number of partitions have to be even. Maybe that's the confusion. All right. All right, so we got the error-bound formula for this guy. Estimate the error in part A. So we're first supposed to find an upper bound for the error-bound formula for this guy. So here's the deal, and this is where the major points came in at. So we got to use this formula. So we first, to be able to use this formula, we got to find k. What is k going to be equal to? Well, remember, my function was given to be 45 over x, better known as 45x to the negative 1. K is the maximum value of the fourth derivative. Again, this is where students lost a lot of points or even gained some partial credit if they screwed up the problem. But if you could at least told us what the fourth derivative was and you got that right, you got half credit on this thing, on this particular section. So I got to go for my fourth derivative. What's the first derivative? This will be negative 45x to the negative 2. What's my second derivative? That'll be 45 times 2, that's 90. 90 times x to the negative 3. What's my third derivative? That's 3 times 90. What's that? Negative 270. X to the negative 4. And one more. My fourth derivative. 4 times negative 270 is 1080 x to the negative 5. Or 1080 over x to the 5th. There is my fourth derivative. But what were my bounds on this integral? Between what? 1 and 5. So this is my fourth derivative, and I got to look between 1 and 5 to figure out the maximum value of this derivative. So, and I'm going to draw it out. I'm not going to use the calculator because it's too easy to do this. So I'm looking between 1 and 5. And my fourth derivative is 1080 over x to the 5th. If I plug in 1, what number do I get? 1080. If I plug in 5, I get this. 1080 divided by 5 to the 5th. I get 0.3456. That's way down there. And I'm going to connect these two guys because it's a continuous function. Where is the maximum value at? Where do I reach my top away from the x-axis? Because it's absolute value, by the way, but these are already positive. So what is it? It's 1080. That's my k value. It's the maximum value of your fourth derivative over the interval. So you need to graph it. And maximum value means absolute maximum. So even if it's down here, if it's farther away from the x-axis, that's the point that I want. And make it absolute value, make it positive. So now we got this. What is my error for the fourth? Is less than or equal to k times b minus a to the 5th over 180 n to the 4th. So my error would be less than or equal to 1080 times b, which is 5, minus a, which is 1, raised to the 5th, divided by 180. And what was n in this problem? We were doing 4 subintervals, so it's 4 to the 4th. And you just crunch out a number. What did I get? 24. It was a large error, but we didn't do very much with it. So the answer to this problem was 24. And the maximum error would be 24 units. And then you got part C. Find the smallest, and too sad that they had to tell you even number because it's Simpson's Rule. You should know it's going to be an even number, so remember that. For the quantity from the formula 0.1, this is supposed to refer to this formula here. They're trying to use textbook terminology here. Which guarantees an error not larger than 3/2. So I want my error to be not larger than, so less than or equal to 3/2. So, but my error formula was equal to 1080 times 5 minus 1 to the 5th over 180 n to the 4th, and we want that to be less than 3/2. And your mission is to solve for n. So how am I going to solve for n on this thing? Personally, I would cross multiply. That would give me 2 times 1080 times 4, cleaning it up as we go, to the 5th, is going to be less than 3 times 180 times n to the 4th power. All right, well, let's just clean that up real quick here. 2 times 1080 times 4 to the 5th is 2,211,840. 2,221,840 is less than 3 times 180, 540 n to the 4th. You with me? Question? Yeah, this is equal to, it doesn't matter. All right, so keep going. What am I going to do to solve for n? Divide by 540. So divide by 540. So take 2,211,840 divide by 540. Whoops, divide, John. There you go. Hit the right buttons here. Divide by 540, and I get this. 4,096 is less than or equal to n to the 4th. Now, what you got to do? Take the 4th root. You can use your 4th root buttons if you want to, or better yet, just raise it to the what? 1/4 power. And what do I get? This was awfully nice. He didn't even have to round on this one. 8 was less than or equal to n, and since 8 is even, there's no rounding up. But just to remind you, if this was an 8.1 or something or other, what would your n value have to be? 10. I don't care what the decimal is, you round up, but 9's odd. Keep rounding, 10. So n has got to be greater than or equal to 8 was my answer. All right. Now, before we guys leave, I've got a few extra minutes in here. I wanted to discuss one other thing with you guys, if I can find it. I'll put it somewhere. Oh, there it is. A lot of folks wanted me to kind of go over this little part here just to show, since I couldn't pass it back to you guys because my grader could not get his job done on time. I wanted to at least show you guys what the free response part of my test looked like. It will not take very long. Also, one other thing, notice this, something very, very important on that final exam. Did you notice that this final exam, the faculty who teach this class, were very disappointed in the final exam for one reason. That one reason was they did not put a pumping problem on this test. After all that work we did on that pumping problems, they didn't put a pumping problem on the exam. Which means you're pretty much guaranteed there's going to be a pumping problem on your final exam because we threw such a big fit about how disappointed we were in the people out of all the work we did on all that physics. So make sure you go back and look at all those interesting pumping problems. And remind you of the formula for pumping problems. For my class, because I have to teach it differently to make you guys understand, work is equal to the sum of the delta force times the distance pumped. What is delta force equal to? Water weight times the delta volume slice. And remember, when you do a delta volume slice, there's only going to be 2 slices you're going to get. You're going to either get a disc or you're going to get a box. So your delta volume here would be equal to pi radius squared, probably an x or something like that, times delta y, because it's changing y as the height here. And for this one, volume would be length times width times the delta y. So there's only two delta volume formulas that you're going to get with this stuff. And what about your water weights? What's the water weight of in the metric system? 9,800. What about the English Standard System? 62.5. Things you should know. Okay? And other than that, and if they typically like to give you guys some kind of weird density, like hot chocolate problem. Remember that one? They gave you the density. Don't forget, if they give you density, it's going to be a metric problem. You've got to multiply it times 9.8 gravity to actually get the weight into it. Does that make sense? Water weight. So take your density and multiply it times gravity, 9.8 on those metric problems. That's pretty classic too. All right. This first problem right here, this is my part 4 of my test. I've got 15 minutes. I can cover this in 15 minutes here. So, here we go. Question? I'll show you after class. We'll talk about it. Okay. So, all right, here we go. Use the integral to figure out this particular series. Use the integral test. The integral test is this. We're going to integrate this series. 3 natural log of x over x dx. I want to use the integral test. From where? From 1 to infinity. What kind of integral is this guy if I'm using the integral test? Improper. You'd be amazed how many people try to integrate this thing and actually didn't do proper techniques of integration, which is what it's about, and you definitely lost some points. This is the limit as a approaches infinity of the integral from 1 to a of 3 natural log of x over x dx. Classic U-Substitution, I would let u equal to the natural log of x, du equals 1 over x dx, which turns this problem into the integral of 3u du, which this thing now turns into 3u squared over 2, which turns into the limit as a approaches infinity of 3 over 2 times the natural log of x squared. Evaluated from 1 to a. Fundamental theorem of calculus, plug in top minus plug in bottom. So this is the limit as a approaches infinity of 3 halves times the natural log of a squared minus 3 halves times the natural log of 1 squared. What's the natural log of 1? 0, so that goes away. What's the natural log of infinity? And so this will be 3 halves infinity squared, which is infinity. So I've got what for the integral? It does what? Diverges. So if the integral diverges, what is the series going to do? Diverges by the integral test. So this series right here is going to diverge because we use the integral test. But I wanted to see proper techniques of integration being an improper integral. You got to do the work right, especially when you show your work. Next one. This is about as fast as I could make it. Given an alternating series, n goes from 1 to infinity of negative 1 to the n. Is the series absolutely convergent, conditional convergent, or divergent? How do you test for, in this order, we always test for absolute convergence first. So take your series and take the absolute value of it. Negative 1 to the n over n squared. But when you take the absolute value of it, so we're testing for absolute convergence here. Now, the negative 1 to the n goes away, and that gives me 1 over n squared. N goes from 1 to infinity. What kind of series is this guy? P series. P is equal to what? 2. What is it going to do? Which is bigger than 1 for those people like that. Which is what? Converges. So this series converges. So what about this series here? The sum as n goes from 1 to infinity of negative 1 to the n over n squared. What kind of series is it? It's absolutely convergent because this guy was a P series. And this is the work I was looking for to get absolute convergent here. Next thing you're supposed to do is find S3, and there's my typo there, 3 terms here. So S3 would be equal to plugging n equals 1, n equals 2, and n equals 3 into this thing, into the original series. Plugging in is 1, and this messed up a lot of people because my answer ended up being negative. Negative 1 over 1 squared, plus plugging in 2, negative 1 squared is 1 over 2 squared. Plugging in equals 3. That's back to minus 1 over 3 squared. So I end up getting negative 1 plus 1/4 minus 1/9. I end up getting 0.86, negative 0.8611111. So there's my answer. I wanted 3 decimal places, negative 0.861. What is the maximum error? The error for Riemann sum is the difference between the true sum and the partial sum. And remember, it's always less than or equal to bn plus 1. But in this problem, n is 3, so this would be b4. And the b4th term would be basically 1 over 4 squared, which is 1/16, which is 1 divided by 16 is 0.0625. 0.0625. So the answer I would take is 0.0625, but officially, if you wanted me to take off points for it, I did say 3 decimal places. So what would that be? 0.063. But I decided not to take those points off. And if you gave me 0.0625, Merry Christmas. All right. Give the power series and find the interval of convergence of this guy. Well, given this power series, find the interval of convergence. Now, most people, you can use the ratio test on this one. I think 99% of my students did that. But look at this problem. I just tried to show you because I did a problem just like this on the final exam. These are just nothing but numbers to powers of n. I don't have anything extra on it. So what could I have also used? Geometric series. And that was easier to use. The geometric series is AR to the n minus 1, since it's starting at 1. So this would be the sum as n goes from 1 to infinity of x plus 1 times x plus 1 to the n minus 1 over 4 times 4 to the n minus 1. I just pulled off one of these guys. So this gives you the sum as n goes from 1 to infinity of x plus 1 over 4 times x plus 1 over 4 to the n minus 1. Now remember, a's can be constants or they can be variables. It's okay to have an a as a variable. Here is my a, here is my r that's being raised to the n minus 1. So r is actually x plus 1 over 4. And to make a geometric series converge, all you have to do is take n plus 1 over 4 and set it less than 1. Absolute value of r has to be strictly less than 1. This gives you negative 1 is less than x plus 1 over 4, which is less than 1. Which is negative 4 is less than x plus 1, which is less than 4. Which when you subtract 1, and that's the sad thing I saw on this test too, when you subtracted 1, what's minus 4 minus 1? Clearly negative 3. No, it's negative 5 is less than x, which is less than 3. So the answer is negative 5 to 3. That's what I was looking for. And the beauty of using the geometric series is you don't have to test your endpoints. But if you use a ratio test, you got the same thing, but when you tested your endpoints, neither one of them worked. So I would have accepted it either way. This one tends to kill a lot of students here, so let's do this one. Here, find the power series interval of convergence. This is using the power series representation formula. You're trying to turn this thing into a over 1 minus r, so I can turn it into the new improved geometric series. N goes from 0 to infinity of ar to the n. And remember, it converges when the absolute value of r is less than 1. So I've got this f of x is equal to 4x over 2 minus x. What's the first thing I want to do to turn it into this formula is I want to make sure this 2 turns into a 1. How do I do that? I'm going to multiply by a half on the numerator and the denominator. That's going to give me 2x over 1 minus x over 2. You do have to distribute. This tells me now I've got in my form a is equal to 2x, r is equal to a positive x over 2 because the negatives line up, so r is x over 2. So plugging into my series formula, this is the sum as n goes from 0 to infinity of a, which is 2x, times r, which is x over 2, raised to the n power. But you were supposed to clean it up. So this is equal to the sum as n goes from 0 to infinity of 2x times x to the n divided by 2 to the n. Now, I've got a 2 on the top going with this 2 on the bottom. So this turns into, I guess I got room to write it here. This turns into the sum as n goes from 0 to infinity of x to the n plus 1. X times x to the n is x to the n plus 1. But 2 divides, cancels with one of those x to the 2 to the n's, gives me 2 to the n what? You got it, minus 1. So my series is the sum as n goes from 0 to infinity of x to the n plus 1 over 2 to the n minus 1. What is my interval of convergence? The absolute value of r has to be less than 1, which absolute value of x over 2 is less than 1, which means negative 1 is less than x over 2, which is less than 1, which means negative 2 is less than x, which is less than 2. So it's between negative 2 and 2. And you do not have to check your endpoints because it's the power series representation from the geometric series.
So if we left it like that, like not cleaning it up, we want to change like that?
Well, you're supposed to. I'm trying to get you guys to look, because they're going to do this kind of stuff to you guys on multiple choice questions, and this is the kind of way they write their answer. I probably would have accepted this, but just been very disappointed in you. Okay. So now, number 5A. From memory. Here, 3 points. I'm asking you guys to memorize formulas, because that's what a lot of part of this exam is going to be, what you know. What's the power series, the Maclaurin Series expansion for e to the x? We beat this one to death. I'll be disappointed if they don't put this question on the exam. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot, dot, dot. You can put 1 factorial here if you really want to. Don't care. Pure memorization. So now, what is the power series for e to the 3x? This will be 1 plus 3x over 1 factorial plus 3x squared over 2 factorial plus 3x cubed over 3 factorial plus dot, dot, dot. Good enough. All right? Catch a pattern here. But so you want to clean this guy up. This is 1 plus 3x plus 9x squared over 2 factorial plus 27x cubed over 3 factorial. And I did ask for what? 5 terms here? I should write out one more. It'll be 3x to the 4th, and 3 to the 4th is actually 81x to the 4th over 4 factorial. That's what I wanted. 1 plus 3x plus 9x squared over 2 factorial. That's a 9. Plus 27x cubed over 3 factorial plus 81x to the 4th over 4 factorial. Why do I care? Because I wanted you to use the first 3 terms, integrate this thing between 0 and 0.5. So the integral between 0 and 0.5 of e to the 3x, which is 1 plus 3x plus 9x squared over 2 factorial, is equal to x plus 3x squared over 2 plus 9x cubed over 3 times 2 factorial, evaluated from 0 to 0.5. Fundamental theorem, plug in top minus plug in bottom. This is 0.5 plus 3 times 0.5 squared over 2 plus 9 times 0.5 cubed over pretty much 6. 2 factorial is 2 times 3 is 6. And minus, when I plug in 0, I get 0. So now I get this. 0.5 plus 3 times 0.5 squared divided by 2 plus 9 times 0.5 cubed divided by 6. I got 1.0625. Did you guys get that? Okay. Now, again, other applications of this thing is this. I wanted you guys to take the limit. This I stole off of web work. Take the limit as x approaches 0 of 1 plus 3x minus the power series e to the x, using the 5 terms up here, which is 1 plus 3x plus 9x squared over 2 factorial plus 27x cubed over 3 factorial plus 81x to the 4th over 4 factorial, dot, 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 all over x squared. Now, doing the algebra on this thing, this is equal to the limit as x approaches 0 of 1 plus 3x minus 1 minus 3x minus 9x squared over 2 minus 27x cubed over 3 factorial minus 81x to the 4th over 4 factorial. All over x squared. What cancels out on this thing? The 1's cancel and the 3x's cancel. This leaves you with the limit as x approaches 0 of negative 9x squared over 2 minus 27x cubed over 3 factorial minus 81x to the 4th over 4 factorial divided by x squared. But if I divide each one of these terms by x squared, what cancels? X squared cancels here. This one cancels, leaves me with an x. This one cancels, leaves me with x squared. Now, when you start making x equal to 0, this term goes away, this term goes away. What are you left with? Negative 9 halves. That was the answer. Negative 4.5. It's a beautiful web work problem. All right. Show your work on finding the Taylor series. I warned you guys, got to know your Taylor series formula. F of x equals f of a plus f prime of a times x minus a over 1 factorial plus f double prime of a over 2 factorial times x minus a squared plus dot dot dot. All right, so I gave you this problem and I wanted the first 3 non-zero terms. So f of x was equal to the cosine of pi x. Here's what messed up a lot of people. What's the derivative? What's the derivative of cosine? Negative sine of pi x times derivative of the inside. Chain rule times pi. Calc 1. What's your second derivative? What's the derivative of negative sine? Derivative of sine is cosine, so negative sine would be negative cosine of pi x times pi times another pi makes it a pi squared. Pi times pi. Every time I'm doing it, I got another pi from the chain rule. What's the third derivative? Third derivative of negative cosine is back to sine of pi x times pi cubed. And then the fourth derivative of x, derivative of sine is cosine of pi x times pi to the 4th. Now we're supposed to plug in 1 into this thing, because my centering point is at 1. So f of 1, f prime of 1, f double prime of 1, f triple prime of 1, f fourth prime of 1. What's the cosine of pi? Negative 1. What's the sine of pi? 0 times pi is still 0. What's the cosine of pi is negative 1 times that negative is 1 times pi squared. Sine of pi is 0. And the cosine of pi is negative 1 times pi to the 4th is negative pi to the 4th. So now all I got to do is plug it into my formula, so I can go straight to the formula here. The cosine of pi x is equal to f of a, which is negative 1. Let me just write it over here. Cosine of pi x would be negative 1 plus 0 over 1 factorial times x minus 1 plus pi squared over 2 factorial times x minus 1 squared plus the third derivative, which is 0 over 3 factorial times x minus 1 cubed plus negative pi fourths over 4 factorial times x minus 1 to the 4th. But these terms are 0, so I get negative 1 plus pi squared over 2 factorial times x minus 1 squared. This will be a minus pi to the 4th over 4 factorial times x minus 1 to the 4th. That's what I wanted. First 3 non-zero terms. First 3 non-zero terms. And the last one, the bonus, which was worth 3 points total, 6 points on this particular part of the test, is this. What's the binomial formula for 1 plus x to the k? 1 plus kx plus k times k minus 1 over 2 factorial times x squared. I should have said more than just 3 terms because I meant 4. So let me give you 4. K times k minus 1 times k minus 2 over 3 factorial times x cubed plus dot dot dot. There's bonus points right there. Just memorize the formula. So if they give you 1 plus k to the half, you can actually just get the answer. Don't forget to do a bunch of pump problems because it's going to be on your exam, and I hope this has been helpful. Don't forget to look at other old final exams as well. I'll see you guys tomorrow.